tire range from 18.5 to 55 tons. The Avatar range of trucks comes with multiple options of axle configuration, loading spans, cabins, suspension, and drivetrains on a single platform that offers you a whole new trucking experience. Our vehicles serve our customers in remote locations, and we ensure that every vehicle is fitted with monitors that track its vital parameters. With an early warning system, we make sure no one is left stranded. The joy of children using our product inspires us. Innovations in our school buses have always kept children's needs in mind. We also make sure that they are the safest buses on the road. We are working towards using cleaner energy sources to drive our vehicles. Our electric vehicle program is set to redefine the future of environment-friendly transportation. Our greatest test, however, is a matter of national security. We are the largest supplier of logistics vehicles to the Indian Army. Our vehicles perform under the toughest conditions on our national borders. Our engines not only help safeguard our nation, but also help power businesses. The power solutions we provide are amongst the most reliable in the market. Our belief in partnership for growth has kept customers' progress at the heart of every solution we provide. To us, partnerships happen on many levels. Our driver training institutes have produced close to 1 million highly skilled drivers across the country. In the remotest villages of India, we have revolutionized the way children are being educated. Through key collaborations and innovative teaching methods, we are empowering the children of our villages. To us, mobility is more than just the business we are in. In our world, it signifies progress. It means enabling success to our customers, enhancing their lives. Mobility for us is everything in life.
In this shifting, driven world, the one thing you can be sure of is change. It's tough to stay ahead, but that's okay, just as long as you always know who to count on. We are Cummins. We create the power solutions people depend on. It's what we've done for more than 100 years. Sure, all that history makes us proud, but the future pulls us forward. However good we are today, we know the best is yet to come. Our business is endlessly shaped by our customers. What they need defines us. And what they say makes us stronger. Who are they? Everybody. But whether their challenges are personal or global, we do everything in our power to solve them. Because no matter where you're headed, we've got your back. And we're with you all the way. And we never forget how our actions impact the people and the world around us. So whenever there are choices, we make sure we do the right thing. This is what we do to power a more prosperous world. And that is never going to change. That's why we're always trusted, always innovating, always customer-driven, always responsible. For a world that's always on.
Welcome to the world of Tata Steel. A flagship company of the global business conglomerate, the Tata Group. Tata Steel is one of the world's most geographically diversified steel producers, with operations and commercial presence across the world. The story began with the dream of one man, Jamsetji Nusserwanji Tata, a pioneer, a visionary, a man ahead of his times. He had his heart set on building a steel plant in India that would compare with the best globally. His dream was brought to fruition by his son, Dorabji Tata, and thus was born Tata Iron and Steel in Jamshedpur in 1907. At the turn of the 21st century, fueled by its global aspirations, Tata Steel expanded its footprint to Southeast Asia in Singapore and Thailand. Acquisition of Chorus in Europe in 2007 placed it amongst the top global steel companies in the world. In 2015, Tata Steel set up a state-of-the-art integrated steel plant at Kalinganagar, Odisha in India. The Phase 2 expansion of Kalinganagar steel plant from 3 million TPA to 8 million TPA is currently underway. The company is all set to pursue domestic growth with its acquisition of Bhushan Steel Limited and the steel business of Usha Martin. This forms part of the overall strategy to increase its India footprint, build capacity in long products, and enrich the product portfolio. Besides steel manufacturing facilities, the company has mining assets in the state of Jharkhand and Odisha in India. Tata Steel has evolved into a leading steel manufacturer, catering to diverse market segments. In its trend-setting journey, spanning more than a century, Tata Steel has contributed immensely towards the well-being of the planet and people. Guided by its vision to be the global steel industry benchmark for value creation and corporate citizenship, Tata Steel is poised to lead the future.
At Bharat Forge Limited, we don't believe in pause buttons. 50 years ago, we hit play, and we haven't stopped since. We move, we go places, and we take our legacy with us. We started small, but our dreams were big. And we chased them tirelessly with all our heart. That's what brought us to the top. To the world's biggest names. And to people's lives. We're committed to partnering greatness, no matter where we go. From India to Germany, to France to Sweden, and now USA. We always go that extra mile and bring the best to wherever our clients are, and we never settle. Over 50 years, we have pioneered innovations across fields. Our expertise keeps sharpening. Our credits keep increasing. And our relationships, they only keep growing. We are fueled by our dreams. Inspired by the next possibility. We nurture ideas, give them wings, make them soar. We seek to build a better, smarter, and brighter tomorrow. And we will. Because that's just who we are. Driven, caring, innovative, and unstoppable.
At Ashok Leyland, we've been in the business of mobility for close to 70 years. We are a part of the Hinduja Group, a transnational conglomerate spread over 100 countries and 6 continents, with diversified business holdings across 10 verticals. Today, we are the second largest manufacturer of commercial vehicles in India. We are the third largest manufacturer of buses worldwide. We are present in more than 50 countries, besides being market leaders for buses in Sri Lanka and Bangladesh. We have a significant presence in the countries of the Gulf Cooperative Council and Africa, dominating in the bus and truck segments. Our products reach out to over 70 million people. Yet every day, we strive to find new ways of enhancing the lives of the people around us. We're constantly innovating for the future, helping redefine mobility, designing better products, and finding better ways to produce them. Our products are defined by their practicality and functionality. Every customer solution we provide is driven by thoughtful innovation. With the introduction of BS6, Ashok Leyland has taken the proven IEGR technology up a notch to introduce the iGen 6 engine technology, which enhances the engine performance and durability further. With lower diesel exhaust fluid DEF consumption and compact design, iGen 6 lowers the cost of operation, offers better fluid efficiency and low maintenance. The unique mid-NOx strategy ensures overall lower cost of ownership. Avatar is a revolutionary, industry-first modular truck platform from Ashok Leyland that is powered by the iGen 6 technology. Avatar's incredibly diverse range of options lets you customize your truck based on your load, terrain, and application requirements, spread across the entire range from 18.5 to 55 tons. The Avatar range of trucks comes with multiple options of axle configuration, loading spans, cabins, suspension, and drivetrains on a single platform that offers you a whole new trucking experience. Our vehicles serve our customers in remote locations, and we ensure that every vehicle is fitted with monitors that track its vital parameters. With an early warning system, we make sure no one is left stranded. The joy of children using our product inspires us. Innovations in our school buses have always kept children's needs in mind. We also make sure that they are the safest buses on the road. We are working towards using cleaner energy sources to drive our vehicles. Our electric vehicle program is set to redefine the future of environment-friendly transportation. Our greatest test, however, is a matter of national security. We are the largest supplier of logistics vehicles to the Indian Army. Our vehicles perform under the toughest conditions on our national borders. Our engines not only help safeguard our nation, but also help power businesses. The power solutions we provide are amongst the most reliable in the market. Our belief in partnership for growth has kept customers' progress at the heart of every solution we provide. To us, partnerships happen on many levels. Our driver training institutes have produced close to 1 million highly skilled drivers across the country. In the remotest villages of India, we have revolutionized the way children are being educated. Through key collaborations and innovative teaching methods, we are empowering the children of our villages. To us, mobility is more than just the business we are in. In our world, it signifies progress. It means enabling success to our customers, enhancing their lives. Mobility for us is everything in life.
In this shifting, driven world, the one thing you can be sure of is change. It's tough to stay ahead, but that's okay. Just as long as you always know who to count on. We are Cummins. We create the power solutions people depend on. It's what we've done for more than 100 years. Sure, all that history makes us proud, but the future pulls us forward. However good we are today, we know the best is yet to come. Our business is endlessly shaped by our customers. What they need defines us. And what they say makes us stronger. Who are they? Everybody. But whether the challenges are personal or global, we do everything in our power to solve them. Because no matter where you're headed, we've got your back. And we're with you all the way. And we never forget how our actions impact the people and the world around us. So whenever there are choices, we make sure we do the right thing. This is what we do to power a more prosperous world. And that is never going to change. That's why we're always trusted, always innovating, always customer-driven, always responsible. For a world that's always on.
Welcome to the world of Tata Steel, a flagship company of the global business conglomerate, the Tata Group. Tata Steel is one of the world's most geographically diversified steel producers, with operations and commercial presence across the world. The story began with the dream of one man, Jamsetji Nusserwanji Tata, a pioneer, a visionary, a man ahead of his times. He had his heart set on building a steel plant in India that would compare with the best globally. His dream was brought to fruition by his son, Dorabji Tata, and thus was born Tata Iron and Steel in Jamshedpur in 1907. At the turn of the 21st century, fueled by its global aspirations, Tata Steel expanded its footprint to Southeast Asia in Singapore and Thailand. Acquisition of Chorus in Europe in 2007 placed it amongst the top global steel companies in the world. In 2015, Tata Steel set up a state-of-the-art integrated steel plant at Kalinganagar, Odisha in India. The Phase 2 expansion of Kalinganagar steel plant from 3 million TPA to 8 million TPA is currently underway. The company is all set to pursue domestic growth with its acquisition of Bhushan Steel Limited and the steel business of Usha Martin. This forms part of the overall strategy to increase its India footprint, build capacity in long products, and enrich the product portfolio. Besides steel manufacturing facilities, the company has mining assets in the state of Jharkhand and Odisha in India. Tata Steel has evolved into a leading steel manufacturer, catering to diverse market segments. In its trend-setting journey, spanning more than a century, Tata Steel has contributed immensely towards the well-being of the planet and people. Guided by its vision to be the global steel industry benchmark for value creation and corporate citizenship, Tata Steel is poised to lead the future.
At Bharat Forge Limited, we don't believe in pause buttons. 50 years ago, we hit play, and we haven't stopped since. We move, we go places, and we take our legacy with us. We started small, but our dreams were big. And we chased them tirelessly with all our heart. That's what brought us to the top. To the world's biggest names. And to people's lives. We're committed to partnering greatness, no matter where we go. From India to Germany, to France to Sweden, and now USA. We always go that extra mile and bring the best to wherever our clients are, and we never settle. Over 50 years, we have pioneered innovations across fields. Our expertise keeps sharpening. Our credits keep increasing. And our relationships, they only keep growing. We are fueled by our dreams. Inspired by the next possibility. We nurture ideas, give them wings, make them soar. We seek to build a better, smarter, and brighter tomorrow. And we will. Because that's just who we are. Driven, caring, innovative, and unstoppable.
At Ashok Leyland, we've been in the business of mobility for close to 70 years. We are a part of the Hinduja Group, a transnational conglomerate spread over 100 countries and 6 continents, with diversified business holdings across 10 verticals. Today, we are the second largest manufacturer of commercial vehicles in India. We are the third largest manufacturer of buses worldwide. We are present in more than 50 countries, besides being market leaders for buses in Sri Lanka and Bangladesh. We have a significant presence in the countries of the Gulf Cooperative Council and Africa, dominating in the bus and truck segments. Our products reach out to over 70 million people. Yet every day, we strive to find new ways of enhancing the lives of the people around us. We're constantly innovating for the future, helping redefine mobility, designing better products, and finding better ways to produce them. Our products are defined by their practicality and functionality. Every customer solution we provide is driven by thoughtful innovation. With the introduction of BS6, Ashok Leyland has taken the proven IEGR technology up a notch to introduce the iGen 6 engine technology, which enhances the engine performance and durability further. With lower diesel exhaust fluid DEF consumption and compact design, iGen 6 lowers the cost of operation, offers better fluid efficiency and
A very good morning to all. I think all the panelists have joined and we'll start in another 2 minutes at sharp 10. Dr. Anuradha, can we start?
Yes, please.
It would, yeah, video. Yes. Would be good if all the panelists could actually switch on there. Thank you. So a very good morning to one and all. I would like to welcome all the esteemed panelists and participants to the second day of CII Global Innovation Conclave 2021. The conclave celebrates India's rising trajectory over several years in the Global Innovation Index from a rank of 81 in 2015 to 46 this year. Before we begin, I would like to request all the speakers to keep their mics on mute and unmute while you are speaking. Our esteemed speakers for the session today are Ms. Neha Mishra, Technical Manager, Customer Engineering, Cummins Technologies India Private Limited, and Mr. Tejas Kinjawadekar, Simulation Leader, EBU, Cummins Technologies India Private Limited. I would now like to first introduce and then invite Dr. Anuradha Ganesh to take the session forward. Dr. Anuradha Ganesh is Director and Chief Technical Advisor at Cummins Technologies India Private Limited and also is an adjunct professor at Center for Policy Studies, IIT Bombay. She advises on the future technology trends, regulatory policies, R&D, innovation policies, and has been guiding Cummins to build strategic technology and product pipelines. She also advises on university and government collaboration areas and strategic partnerships. She is currently serving in various national level committees, and at CII, she is representing Cummins as a subject matter expert too. A PhD in chemical engineering, Dr. Anuradha brings in a unique combination of excellence in academia and industry. So welcome, Dr. Anuradha, and I request you to take the session forward. Thank you.
Thank you so much, Namita, and thanks for this opportunity that, I'm starting the day on innovation, so that feels good. All right, so welcome friends again. With an objective to initiate innovation as a movement in India and globally, CII is working on various initiatives, and one of which is the CII Innovation Talk Series. And under this initiative, on behalf of the Technology Committee and on behalf of Cummins, of course, I would like to introduce the speakers who would be talking to you today on analysis-led design, analysis-led product development, and we do know that simulation and modeling is an excellent intuitive tool to help innovate at low cost, much faster, and the first time right. It also helps in predict the behaviors in the early design stage. And I can go on, but I'm going to allow these speakers to speak. So I have the privilege of introducing my speakers. The first one, I think together they have divided the whole talk in a very, very nice way. So I'm going to introduce both, not saying who's going to talk first or who's going to talk second. Neha Mishra, who's a leader, corporate customer engineering and R&D, and a very dear colleague of mine. She has completed her master's in control systems engineering from IIT Delhi and joined the Indian Space Research Organization at the Vikram Sarabhai Space Center, Trivandrum. She was responsible there for design and validation of digital autopilot for launch vehicles, mostly for upper atmospheric stages. She then joined Eaton Corporation in 2010 and was working on hybrid vehicle controls. She joined Cummins in 2017 and is leading the corporate customer engineering and research and technology groups. In her current role, she is responsible for developing process and tools for simulation-based product development and support end customers have effective installation of Cummins products and their applications. She has a patent and in microgrid control and several papers and national conferences. She is passionate about the system simulations and controls and takes pride in having to work on many variants of applications and controls. Welcome, Neha, and I'm sure you're going to enjoy. And before you take over, let me also introduce Tejas Kinjawadekar, our simulations leader, EBU Engineering. Tejas has completed his master's in mechanical engineering from the Ohio State University and joined Cummins in US in 2010 in advanced engineering, developing the system simulation tools for various platforms and using them for developing electronic horizon-based fuel economy features and hybrid solutions for commercial vehicles. He then led the Virtual Integration Center, about which he's going to talk to you about today, a multidisciplinary simulations team focused on machine integration. In his current role as a simulations leader for the engine business unit in India, he's driving simulations-based product development in the organization and leading the systems performance analysis team. He's a certified Six Sigma Black Belt, has 4 patents, and has served on the board of SAE Indiana chapter. He is passionate about the initiatives related to sustainability of our planet and is actively involved in Cummins Planet 2050 initiative. And I think it's the right time to say that simulations-based or analysis-led design definitely contributes to reducing the carbon footprint in some way or the other. With this, over to Neha and Tejas. Neha, I understand you're going to start first. Over to you, and I really know that the audience are going to enjoy the talk. Thank you so much. Over to you, Neha.
Kind words. Thank you. Just to save the bandwidth, I'll be switching off my video. I've got some unstable internet, so just a disclaimer in the beginning.
Neha, you'll need to speak a little slowly.
Sure.
Thank you.
Please, someone can confirm if my screen is visible to all.
Yes, yes, it is.
Yes.
Okay, so good morning, everyone. It's our extreme pleasure and we feel honored to actually deliver a talk on simulation-based product development. We would be talking about the journey which Cummins has taken from an analysis-led design towards a simulation-based product development, an innovative and a creative approach so that we can save money, time, cost, and actually lead to the products which are going to be not only performance-wise optimized, but also robust for the market. So with that, I'll start with an introduction of the topic. What do we actually mean by analysis-led design or modeling and simulation in general? So what you see on the screen is essentially a wiki definition of modeling and simulation. I'll read it for you. Modeling and simulation is the use of models, physical, mathematical, or otherwise logical representation of a system, entity, phenomenon, or process as a basis for simulations, methods for implementing a model, either statistically or over time, to develop data as a base for managerial or technical decision making. I know a very complex jargon of words which are being put together by Wiki, but it wanted to make it really very holistic to define what modeling and simulation is. And if you look at it more carefully, it encompasses everything under the sun when it comes to taking decisions in a product development. So when we look at modeling and simulation, there are typical questions which comes to any kind of concept which is being introduced are the 5 W's and 1 H. Why are we doing it? What are we going to do in modeling and simulation? When it should be done in the product life cycle? Where it should be done? Who should do it? And for whom should we do it? And finally, how it should be done. To look at the question why, modeling and simulation definitely needs to have a purpose. Are we doing it to predict the performance? Are we doing to gain confidence on what we have already designed? Or are we trying to save the iterations? Cost saving is one of the major roles which modeling and simulation plays in a product development. It saves the fuel cost because you're trying to test the vehicles virtually. It is going to remove the iterations which you go before actually cutting the metal. When it comes to what is modeling and simulation, modeling is essentially the physical interpretation of your component, either using simple physical equations from Newtonian or Navier-Stokes equations, develop bases that create a component in a virtual domain which will mimic the behavior as done by the component. Simulations, on the other hand, is a combination of these component models to actually simulate a realistic scenario in a virtual domain. to generate a data. The way we actually test our product onto our test setups or on the field, we collect data. Simulation is also a methodology to collect that data. And finally, definitely, we would like to analyze the data to take decisions. So that's what we do in modeling and simulation. When it should be done, that's a very, very important question. Ideally, modeling and simulation is done entire the life cycle of the product development, right from when you are evaluating the concept all the way it's being introduced onto the field to duplicate the issues if seen on field. It should also be done when there is a value to do it. So where there are more iterations, where there are more testing to be done, that's the place where we have to first introduce modeling and simulation. How it is done? Well, there are tools. There are tools like MATLAB, AMISIM, GD Suite, AbleBoost, you just name them. Those tools enable to create these component models in a virtual things. But I'll say apart from the tools or more than tools, what's more important for an organization to take it forward and use it more effectively is the process. How well modeling and simulation is integrated in your product development process is what's going to make a differentiator overall in this modeling and simulation domain of product development. Where it should be done where the decisions has to be taken, like the wiki definition says, where the managerial or technical decisions has to be taken. A big milestone is coming. So if I look at it from an on-highway application of vehicles, you do a summer trial, you do a cold trial, you are looking at different altitudes, then there are many milestones. Can I do simulations much ahead in time so that you are ready for those kind of actual testing? And finally, who are the doers? Mostly the engineers who are aware of those tools and processes, and the stakeholders. Again, there is a trend which is coming in, and that's what Cummins is encouraging, is the people who are going to use the data should be running these simulations. How can we make these tools more and more user-friendly and effective? We need to gain confidence of our stakeholders at how close it is from the real time. And finally, in the product development cycle, it should also enable independent verification and validation. So this is, in a nutshell, is mostly around modeling and simulation. What is industry approach for simulation? Any software or requirement change triggers a unit testing. You start implementing that requirements. Once you have implemented that requirement, you start trying to test it in a modeling loop simulation. Eventually, you take it to a processor in loop simulation, trying to evaluate whether in the realistic scenario, are we going to have impact on the time responses? Is it having enough memory, and so on and so forth? It leads to hardware in loop simulations. Then it goes to vehicle testing, certification, and eventually the life cycle assessment. So if I look at it from the entire product life cycle, from the concept or the requirements to all the way to the sustainability of that component or product into the field, system simulation has a role to play everywhere. So what you now see on screen is essentially the V diagram of modeling and simulation. You start looking at modeling and simulations right from the time when the analysis and metric requirements are being laid down. So there's a new requirement coming in. That's the same time when you're actually trying to capture those in your simulations as well. Simulation analysis design starts, you do a component model design, then you start integrating these components together to put together a subsystem. And finally, simulation of is integrated and seen as an application. And finally, the simulation execution and evaluation happens towards the end of your product development. So this is a typical V cycle, which you have already might have seen it for product development. There's an internal V to that product development, which is owned by the model development teams. And one thing which is very, very key, and another new thing which Cummins is doing, is having a repository of these models, because we need to have them for baselining it for a new product development or a new model development, if I may use that term. And we also might need it when there is an issue onto the field, and at that time we may not have our own products or the test benches available to test it. So these model repositories becomes a kind of a big database from where we can take decisions fairly quick without waiting for a duplication of issue onto the vehicle. So that's what is an approach today, more and more simulation for product development from cradle to grave. And that's the journey which Cummins is taking today, from an analysis-led design, from simulation for innovation in product life cycle. Simulations essentially enable a lot of innovation right in the technology exploration area. When you're evaluating concepts, when you do not have a liberty to actually cut metal, because you're trying to make sure whether this concept is going to add value, and be a feasible product by the end of the day. So that's the time that simulation plays a key role in the technology exploration phase of a product life cycle. You actually go into a product innovation when the new product is getting developed. So you have evaluated a concept, you have a fairly great confidence on that concept, and now you're trying to build the actual product. And that's where a lot of innovation comes in when you're trying to optimize the performance. You may not be able to do it if you're doing a hardware iterations. All the iterations, all the combinations can be taken care in the simulation environment. And the other concept which is coming up in the industry nowadays is we just do not only need a performance which is optimal, we are also looking for a robust performance. So if you look at it from, again, an on-highway application, the truck which is going to be bought in India is not going to be restricted in one location itself. It's going to go from high altitudes in Leh Ladakh to all the way to sea level in Chennai. And it needs to actually take care of all the variations which comes in from the environment and the usage factor. So to ensure that our product are robust for all of these conditions, we cannot test them, of course. So we can actually simulate those situations and give them a robust product. Another facet where we are putting up a lot of effort of simulations for innovation is in the application engineering domain. Cummins makes engines, and that goes into a host of applications, right from a submarine application to on-highway truck, from an excavator to actually a genset application. So how these machines or the engines which are being developed in Cummins very well integrated onto the application of the end customer is very key for us. And to optimize the performance of the end application is where the simulation has been enabling innovation in Cummins. And finally, the service and maintenance. The product is in the field. It is going to see some issues. A lot of uncertainties is yet not being modeled. And that's where replicating the issue is far more safer to be done in a virtual environment. So in a nutshell, what I'm trying to say is technology evaluation, through product differentiation innovation in the beginning of the product life cycle, product development, optimization of performance and robust, and definitely an incremental innovation through current product support. This is how we have structured our today's discussion. So we are trying to talk about the innovation in Cummins through ALD, through modeling and simulation, through simulation-based product development. So Tejas, my colleague, is going to actually talk about the approach or the process which we have started adopting in Cummins, and we are calling it a simulation-based product development. Post the introduction of the concept, I'll be talking about system simulations, that how do we actually optimize the component performance to ensure that the end customer's requirements are being met. And finally, Tejas is again going to come back and talk about the virtual integration, that how do we actually integrate our components, our products into the end application virtually to make sure that the product is robust and is performing optimally. So with that, I'll ask Tejas to take over a few other slides.
Sure. Thank you, Neha. Thanks for the introduction, and good morning, everyone. So Neha gave us a good background of where simulations fit into the different stages of product development. So what I'll focus on next is this initiative that we have currently, and it's a big part of engineering focus right now in Cummins, which is called simulations-based product development. So if you go to the next slide, I'll start off with what exactly is simulations-based product development, or SBPD, and what kind of makes it different from what we have been doing in the analysis-led design space. So like many companies, Cummins has also been doing analysis-led design for a couple of decades now. A lot of the focus in analysis-led design was at the component level, so that we make sure that we analyze the designs through FEA methods, CFD simulations, so that we have confidence in the design before we actually build prototypes or procure hardware for it. So that was the focus of analysis-led design. But now with this continuous drive of how do we deliver better quality products, and how do we do that more efficiently, so reducing less resources, faster delivery times, and doing all of this as the technology and product landscape is changing, right? So in the short term, we'll have emissions regulations driving a lot of product and technologies. In the long term, we have this challenge of climate change and sustainability. So path to carbon neutral products, circular economies of products. So all of this will keep on changing the products that we have to deliver. And so how do we do that with very high quality and efficiency? So that's the key driver for now, this renewed focus on how do we thoughtfully integrate simulations at every stage of product development. So it's no longer component focused or no longer related to one functional excellence or one technical area, but rather we are looking at every stage and every function of product development, how do we thoughtfully integrate simulations? And to rephrase the quality and efficiency piece, right first time is very linked to the efficiency aspect, because you have to ensure that any system level validation tests or endurance tests that you do, they pass the first time. You don't have to do any rework on that. Or similarly, when you integrate products into your end application, they have to integrate seamlessly the first time. So either you or your end customer shouldn't have to do any rework for that integration. So that's the right first time piece. And the second, as Neha said, Cummins products go into so many different applications, operating in different regions with very different use cases. So it's very important that we assess the robustness of that product for every customer use case. So a lot of the rework that is needed after launch is related to maybe you miss out on some combination of noise factors that then you have to compensate for later on, right? So then how do we build up that robustness during the product lifecycle? And simulations are especially powerful for robustness studies. And the other differentiator of SBPD for us is working on the right problems, right? So for all the diverse global companies, or if you have operations in different regions, different functions, different business units, there is always an element of decentralization of the efforts that go on, right? So one big goal for Cummins was that how do we, at the full company level, looking at current and future technologies, how do we identify what are the biggest problems in the simulation space? What are the main capabilities in the simulation space that we need to first identify and then focus our resources on? So the identification of the right problems to work on is also a big area for this initiative. And then lastly, as much as an innovation challenge, I would also call this a change management problem, right? Because many hardware companies have traditionally relied on hardware testing for product development, right? So your product development timelines, resource planning is all related to when your prototype hardware is available, when your final tool hardware is ready, and so on. Right? So and then there is also this anxiety around how accurate will be the simulations, or can I trust simulations fully or not? Right. So kind of educating the organization, and then laying the focus on thoughtfully integrating simulations and testing. So the goal is not to replace one or to give higher importance to one versus the other, but to pick the right tool for the right use case and thoughtfully integrate simulation. So there's a lot of culture change work that is happening as part of this initiative as well. On the next slide, so this again gives one example, maybe from a controls lens, where your typical product cycle would kind of look from left to right, right? You get a new requirement and you develop a component related to it. Then you assess the performance of the component. For us, being a power solutions provider, meeting emissions is a key requirement. So then you assess if the changes you have made are meeting emissions. Then we are seeing more and more diagnostics regulations come in. So that is then assessed. And then finally, the specific application in the vehicle that your product is going into, that gets validated. And then you deliver it to the customer, right? So now if you treat this as a linear process, and if there's something that causes rework towards the right of this cycle, right? The further right you are in this cycle, the harder it is and the more costly it is to do any rework. And what simulations gets you is kind of have these shorter closed loops running, where as I'm developing my component, I can assess if my performance requirements are met. I can assess if my emissions requirements are met. Am I meeting my customer defined requirements while I'm developing the component? And so it helps to save cost and deliver a better quality product more efficiently. And so going back to my earlier comment on culture change, right? So typically you look at simulations with two lenses. One is the lens of accuracy. So if I have a real physical system, how close are my simulations predicting to that real system's performance? The second lens, which is not used as effectively, is the repeatability of the tool, right? So with simulations, you get almost perfect repeatability, right? Because it's a mathematical model or a physics-based model, which if you give the same inputs, you should get the same outputs every time. So it's a highly repeatable setup. So if you look at the different options that are listed here, starting from field population. So I'll pick a on-highway example, right? So you're testing a truck out in the field, or you're testing multiple vehicles in the field. There are so many different noise factors that come in. How is the driver driving the truck? What kind of operating conditions you are testing on? Uh, what are ambient conditions, traffic, road, all of those things come into play, right? So when you pick a data set from your field population, it's tough to figure out whether it's truly representative of your end population or you're picking up a data set from one of the tail ends of your bell curve. So then and this becomes especially harder when you're trying to assess if whatever improvements you have done, be it a hardware change, be it a calibration change, those improvements are typically incremental, right? So you will have maybe multiple features which add up to, let's say, 5%, 10% fuel economy, but the individual features contribute portions of it. Now, if your variation in the testing is so high that you cannot resolve those differences, then there's a drive to kind of tighten the variation, right? So as you go down this slide, you'll see that with road tests where you have a controlled vehicle running, that's tighter. If you go to a chassis dyno where you remove the ambient condition variations, it helps to reduce the variation further. And then we have engine test cells, and then finally pure simulation, right, where it keeps tightening the band of variation. And the tighter your band is, the easier it is to resolve these improvements. And the more repeatable your simulation is, or your test setup is, the better it lends itself to comparative studies. And going back to my earlier comment on robustness, right? So when you're doing a robustness study, simulations become especially powerful there. Uh, Going to the next slide. I talked about this effort almost like a top-down approach of first identifying what are the right problems to work on, right? In Cummins, as part of our Planet 2050 efforts as well, we are actively working on getting to carbon neutral technologies and circular economy, right? So that is bringing up many novel and unique problems to work on. So then figuring out what are the simulation tools and capabilities needed to work on those. When we talk about, again, uncertainties related to how the product will be used in the field, right? So kind of if we can assess the product performance, the sensitivity of the product performance to those uncertainties in the field upfront, we'll be able to deliver a better product. So there's a lot of focus on how we model these uncertainties and then assess the impact on product performance. Neha also talked about the iterations, right? So the more number of iterations, you start running into timeline and cost challenges if you do everything in hardware testing. So then what are the simulation tools needed specifically to reduce iterations? And then lastly, testing challenges. So though there is a lot of value in hardware testing, there are some very real challenges that you encounter when you're testing, right? So I gave the example of a long hour endurance test. So if we have to do this for one of our bigger engines, right? The biggest engine Cummins makes today is a 95-liter engine. And it takes multiple tanker loads of fuel to complete an endurance test, right? So if something fails in that, there's a big impact on the product development, right? So that's an example. Another example is for industrial applications, when you do a cooling system assessment, you have to load up that machine to its full power and full torque. This is very hard to do out in the field, right? So that's where, again, simulations are really useful, where doing the testing itself is a challenge. And when you look at simulations, I think you have to look at them with these different lenses. So repeatability, accuracy of the model that you have to pick, the cost impact that will have once you have the model in place, and then the flexibility of changing components, right? And then all of these become especially relevant when you're looking at it as a full system. And so what we'll next go into is this system simulations area, which Neha will cover.
Thanks, Tejas. So Tejas did talk about the system simulation-based product development and that it triggers to a system simulation, because whatever we develop, it has to go to an end customer who's going to use it. So Cummins develops engines, after treatments, filtrations, and many other components, which actually goes into different applications. And we are looking at as an innovative approach of can we simulate those and come up with better products. So I'll start with two examples. The first one, our favorite, where our engines majority of time goes in India, is the truck application. So for an on-highway or in industrial application, these are the two places where Cummins engines goes. So what do we do the first thing when we are actually putting together an on-highway application? We like to see how the architecture would look like. So if it's a truck application, we are looking at from a drivetrain perspective, because there's a system level requirements of drivability, of performance, which is going to be from fuel economy. Now, all the on-highway applications or off-highway applications are driven by emissions. So all of these will guide that I should define and develop my drivetrain so that it meets all of these systemic requirements. And if I need to evaluate that, what all are the different options, one heuristic way of is going and actually building those different drivetrains and compare and run a field test. Instead, we are having now tools which can actually do these architecture studies, and they are all available tools in the market, like autonomy, emission hybrid optimization tool, or Simscape, and so on and so forth. Excavators or all the off-highway applications, all the more important for doing these architectural studies, because their hydraulic and pneumatic circuitries also needs an optimization. And here is where the simulation can play a very innovative role and a very crucial role to come up with an optimized drivetrain. Once an architecture is fixed, the simulations are done, or the models are developed which are higher fidelity to evaluate that what is the performance when we put together this in a virtual environment. So what you see as those pictures are essentially the models, and then you run it in a vehicular simulation way and understand that how does it actually impact my systemic performance. Once that's evaluated, what we have seen as a growth, right, from a mechanical engine to electronic engines, and then electronic engines have a lot of controls and controls features. There is a way forward for ADAS and automatic, driver assist, and many other advanced control features will come in. So with these kind of simulations, you can evaluate those new control strategies, one in a pure simulation way, and then it has to be done from an ECM in loop or a controller in loop kind of application simulation. So that's what Cummins is today doing it. Do the architectural studies, do a detailed performance evaluation in a virtual way, and then do a bench testing. Post that, we actually don't stay at the bench level itself. We also create a virtual vehicle. So apart from the Cummins components, we are now putting together the entire vehicle dynamics, drivetrains, excavator hydraulic circuits, and then evaluate the performance at an application level that is my end customer satisfied at the system level when I actually optimize the performance which are under our control from Cummins. And this also leads to the tuning of those parameters before we actually fare it on the vehicle. So that's something we also do it in a virtual environment. So that's one key example. We have been doing it day in, day out for the on-highway application. Another example of where Cummins engines goes in is gensets. So we have something called as basic simulation. So when you actually start having a controller, and then what you normally do as a testing is have a simulated standard inputs given to those controller, and then you actually check against the standard outputs which is expected out of it. It's a kind of an open loop test which is typically done in a basic simulation heuristically for any gensets. And then once that's done, we normally go to a genset, which is actually a hardware, and then optimize the testing. These gensets not only go for, they are in the wide range of applications where they stay. They can be on a local application, they can be on a residential application, or it can be actually in your data centers. And all of them will be seeing a different kind of a duty cycles. So every time a genset goes for a specific application, the control engineers also have to go there and actually tune it for that specific application. So that's the kind of work culture it was existing earlier. And now what we're trying to do is bridge the gap between the basic simulation to a real genset testing through a software in loop and a hardware in loop simulation setups. So how we started doing it? We started putting together the actual hardware models into our loops. So if you see it, we started creating models of the engine, alternators, AVRs, and so on and so forth, and create that in a virtual environment. We call it a simulation. link it to an actual hardware of an ECM, which is engine control module in this case, and then also link it with a genset control module. And that's the setup, which would be kind of a virtual genset testing, where we can evaluate the performance before it actually starts giving you results. Another approach is we can actually make everything in simulation, and not only the ECM and the genset being in hardware, they are also part of the plant models. So now we have a complete simulation setup of a genset. So this is the gap which we have bridged from an open loop testing to a complete virtual closed loop testing of a genset. This enables all our engineers to actually optimize the performance, make the tune gains robust enough for all kind of applications and duty cycles, and then hand it over to the end application. And there are fine tuning to be done. Definitely, it's not something which is like it's going to be 100% when it's being tested on the final application. But all the coarse tuning, all the iterations which typically used to happen on the actual hardware is now being taken care through these virtual environments. So with that, two examples, I would now go a little deeper into what do we mean by system in a system simulation, and how does we build together all these components as a system simulation setup. So from, if I look at it from Cummins context, what are the different components which we have? We have turbo, we have cylinders, bowl, injectors, catalyst, if it's an after treatment. So all of these becomes my components. So I need to actually create models for these components. Where are these models being created? In a very historical way as a CFD simulations, FEA domain, or dynamics. So these are the places where all these components are modeled today. They've become a subsystem, because then you have an engine subsystem, which will have an air handling system, you have a fuel handling system, and all of them put together will actually contribute and make it as an engine subsystem. We'll have an after treatment subsystem, controller subsystem, because all of these individual components would be controlled by certain signals, and all of them put together will now become my integrated controller. And if I look at it in a modeling lens, vehicle dynamics is also a subsystem, because I'm going to integrate my vehicle dynamics or my drivetrains into this entire gamut of things and make it as a subsystem. Now, the moment we start putting together our subsystem models, it has to move out of a finite element domain and become a 1D or a 0D models. The reason being, it has to run at real time or faster than real time to actually set up more DOEs around it. So the tools which are typically used for subsystem modeling are mostly GT power for engine, ADL boost, others for after treatment. These are all 0D and 1D models. And then now we start putting together a system simulation. When we say system simulation, we are now starting to close the loop. So the difference between component and subsystem is these are mostly an open loop setups. You are actually giving a standard inputs and testing it against the standard outputs. The moment we start calling it as a system, we are now closing the loop. We are closing the loop of engine outputs using a control signal. So it becomes an engine plus controller, a closed loop system. We also have an after treatment plus controller. Vehicle, if I'm only running a simulation vehicle with the vehicle control module, we are closing the loop. That becomes my system. And the other thing, which is again an innovative approach, which we have started working from simulation side, was on the super system simulation. So we didn't stop even at engine after treatment, which are our products. We also went and looked at it at a super system level. And what do we mean by super system? All of them put together: engine, controller, after treatment, and the application models, which can be a test cell, which can be a vehicle, or can be a genset. And all of these models are typically called as model in loop, depending on if it's purely a simulation environment or hardware in loop, because you start putting some hardware in these loops, mostly from controls side, ECMs, and certain sensors and actuators. So again, to understand a little more, what is my model development cost when I move from a component to super system? Why is Cummins actually investing into a super system simulation when there is already a component models existing? There is a model development cost, which is lower when you're doing at a component side, but then it of course starts increasing from a super system size. But the impact you have it from the optimized performance is humongous. The test coverage range, now that's where the advantage comes in. If you are looking at a systemic performance, or our stakeholders are looking at a systemic performance of emissions and fuel economy, they may not be able to make out from a component optimization done at a turbo level. The turbo might be optimized for it, but we do not know what is the impact of a turbo change all the way up to my fuel economy or an emission for that matter. So there is a narrow coverage of test ranges when we start from component, And there's a huge coverage when it comes from a super system level and more relevant to our end customers. Of course, model maturity wise, the component models are more detailed because they are done at a very small scale for a smaller component. And then as we actually abstract out the fidelity, and it goes from a high fidelity to a low fidelity at a super system level, because there is where you're looking at it at system level. It is mostly guided by the computational power it requires and the time it takes for simulations. So this is how we actually quantify our systems and system simulations. Another approach Cummins has been following is, what's my duty cycle? So if I look at it again from my application perspective, the engine which Cummins gives to any of our stakeholders, it is going to run in, say, a duty cycle, which is Pune, Bangalore, Pune. Now that's close to 18 hours kind of a duty cycle. Sometimes it's a huge field data of 470 hours. And are we going to run simulations for all of them? If I need to actually have a realistic duty cycle, can I create a short snippet of it? So there was again an effort which was done in-house where we tried to abstract out all the information which was available at a huge chunk of data, but create a shorter duty cycles. So if you look at it on the figures, we had a field data of 470 hours, and using our clustering tools, we actually tried to create a duty cycle. Now this is actual field data short duty cycles. These are not the duty cycles which are abstracted out or a synthetic duty cycle. But that short duty cycle, which is a subset of a field data, includes all the variations which is being captured, which is relevant for our simulations in that 470 hours. So now from that 470 hours, we've come down to a short duty cycles of 2 to 3 hours, which is manageable on simulation environment and would be able to run a lot of DOEs to see the robust performance. How do we do it? The approach is simple. We pick up the field data. We use one set of data for calibrating the short duty cycle and create a short duty cycle. And another set of another set of parameters from the same field data are now used for the validation. So once we are sure that the short duty cycle is a true representation of that field data, we then start having the effective simulations. You've been hearing us talking about a lot on robustness. That's another area which is becoming more and more popular in our end customers' requirements perspective. They would be looking for an optimized performance engine, which is going to take care of all the variability possible in our country, like I talked earlier, right, from an altitude point of view or from the traffic areas, conditions, and the duty cycles it is subjected to. The same engine can actually go for a submarine application, and then it also can be going in for a genset application. And there would be a very different requirements when it comes to vibration and noise when the same engine goes into different applications. So how do I actually make it a robust product? We have come up with a norm, something which we have been, not something new from the industry point of view. We have used the same Six Sigma approach towards it, defining what is my key performance indicator. We started looking at the parameter diagram for the unit under test and see what's my desirable and undesirable outcome. Do a one factor at a time kind of a DOE for the control and the noise factors. The reason why we do it is then we identify what are my critical noise factors, what are my critical or the sensitive control factors, and then we optimize the control factors and try to see the sensitive noise factors run the worst case scenarios. Once we have run the worst case scenarios, we understand that is this current state which my product is at, can it handle the worst case? If yes, then we run a Monte Carlo scenarios. If not, then we have to do something to update our models. And then once that Monte Carlo simulations or a DOE or Taguchi methods are done for the robustness, we are then sure that in the defined noise range, our product is going to meet the end customer requirement. And one thing which is very, very important is we are not doing it at a component level. We are doing it at a system level. So if a stakeholder is going to put the engine into a vehicle application or an excavator application or a genset application, these simulations are done at a system level. And that's why there is more confidence of the robustness of these parameters at the system level requirements. Just some use cases, because we've been talking about a lot of jargon, but how does it look like? So all of these figures are only representative. How do we use simulations, right? So when someone is optimizing the performance, the plot which Tejas was saying, showing around the iterations which are coming as we move from left to right, there were many different software builds and CALs are being developed and at different altitudes. So what simulation can help you tell us what is the variation over a baseline. Very, very effectively, it can tell the difference between the two simulations. Here, I'm talking about not the closeness with the actual field data, but the variation between the two runs. And that is going to give an indication to that component or a subsystem owner that whether that's actually meeting a requirement or not. So the top left figure essentially talks about all of those iterations which any component owner would like to do and see whether it is making sense from improving or impacting the performance at a system level or not. The right top plots talks about the tuning of those parameters. So what you see as the first plot is the untuned response, which is little wavy, hazy, not meeting requirements. It's pretty slow from the reference signal. We tuned those parameters on bench, and then it started following the reference signals really well. Now that coarse tuned gains are then put onto the vehicle and then fine-tuned it so that it starts meeting the requirements. So here we have saved a lot of time. The earlier tuning, which was done on the vehicle or on the test cell, was close to 2 to 3 weeks. That's now being done in a couple of hours, just because all the homework of coarse tuning is done in-house in a virtual environment. We also predicted system level performance and fuel consumption of power and everything in between the two iterations to the two baselines, which you see it here on the left bottom figure. And another very, very big area where we've been impacting is, as you saw that when we develop a product, there are many cross-functional teams involved. Now, all of them have optimized and they've said, okay, this is the optimal product. And one of them realized of those component owners that I need to make a change, a small change into my code, a small change in my product, be it a hardware or a software change. Now, we really need to understand that do I really need to make a change or tune all the parameters, or I'm okay with this one sole change and it's going to not impact it. And that's called as software transparency or a performance transparency. So we've been running these transparencies for kind of simulations for a lot of product development cycles, and that's been helping us to optimize the performance and make it more and more robust, because we do not have to, these simulations give them an indication, oh, you have to tune few parameters now because someone has changed it. So it's not a surprise in the end. Or it actually says, no, you don't have to make a change in any of the other components. They stay as tuned as they were in the beginning before this change has been made. So these are the couple of use cases which Cummins has been doing it using the simulation-based product development. So there are some immediate and tangible benefits from simulation-based product development. We talked a lot about software transparencies, diagnostics, control initial tuning and testing. So these are something which is very, very apparent, and there were low-hanging fruits. And over a couple of years, last couple of years, we have been saving more than 1 month each of test cell and vehicle testing at any given product development which we are doing. So we are saving a lot of cost, fuel, driver time, and many other things while we are doing these software simulations. Robustness, I think we did talk a lot about it. That's something which we are trying to achieve using these. There are other additional intangible benefits, right? The off-nominal cases. Sometimes our test cell doesn't have a capacity to test few of these test scenarios. We don't want to actually go for a high altitude test or cold or hot testing. Like today, if someone wants to do a hot testing, we are not in summers. We have to wait for another 6 months, but the simulation platform can provide you data of the summer testing, in actually very hard winters. Access to the virtual test cells and vehicle test cells, we are actually providing them. They can be put up in many systems, and then you can actually have a virtual test cell sitting in many laptops instead of booking a test cell, which is costly, and then you don't get the time also quite often. And current product support. This is something which is intangible since this is new concept. A lot of products are already in field, and then there's a cultural shift. Again, Tejas was talking about, right? People say it's been working, so why do I need to actually model it? But the thing is, when you actually see something failing, you can come back and make a change using these models more effectively. So that's something which we are trying to take a note of it, use it, and then eventually tell that, even the current product support is going to have a huge benefit using these methodologies. Another example, Cummins is also venturing into the alternate power solutions. So electric transit bus evaluation of the drivetrain. So not only the conventional diesel drivetrains we are talking about, we are also talking about the electrified drivetrain and how can we actually select simulations. We have very good simulation models of the driver behavior, so you can actually see whether we have an aggressive driver or a calm, composed driver, and so on and so forth. So we run all of these simulations for power train sizing scenarios or route-specific simulations. And this is, I think, one of my last slides on the system simulation topic. We are also moving towards realistic simulation. So, what next? What next in the modeling and simulation domain? So we did the performance, we did the robustness pieces of things. We are now actually reaping the benefits of all of these. But the next thing is there will be more and more advanced control features which will come onto the vehicles. There are advanced sensors which will now installed to enable those advanced control features on the vehicle and on all the different applications. There'll be many different vehicle and powertrain systems which will come up. There'll be a lot of safety controllers which will come up. There'll be a lot of safety requirements which will be coming up onto the applications. So how are we going to integrate all these many different types of controllers and simulated? So realistic simulations becomes a very, very key thing in modeling and simulation domain. And that's what we are working now. So we are now trying to integrate our detailed high fidelity models integrated with the realistic simulation, simulate traffic situations, simulate traffic congestions, speed limits, what kind of vehicle dynamics, it would be the road conditions, and all of those simulations will come up. So we now, again, if you remember Tejas's plot on the variability, we started with a pure simulation. We are now able to do a virtual dyno. We are able to do a virtual vehicle, but still the variability of the road and traffic congestions was not there. So once this innovation or this kind of capability is developed, we'll again start having those kind of uncertainties also imbibed into our simulations. So finally, takeaway from a system simulation perspective, optimal and robust performance is a need. Simulation enables innovation for right first time and reduces time to market. And the other thing which leads us to the next topic is virtual integration. So once this is being done, how well my components are installed onto the end application. And Tejas is going to talk through us on the virtual integration side. Tejas?
Thanks, Neha. So we're now heading into the last leg of our presentation today. Cummins being a power solutions provider, it's very important for us that we make the integration in the end application as seamless and efficient as we can, and engage with our OEM partners to deliver a product that is optimized for their use case or their own customers. So with that thought, there is a team here in India called the Virtual Integration Center, which was developed specifically on how do we use simulation capabilities to better integrate Cummins products. Okay, so it's a multi-domain simulations team focused on machine integration. And so what types of analysis we do, we'll cover that in the upcoming slides. But having a central team, so again, when we talk about simulations-based product development, right, there are different strategic elements to it as well. What kind of tools you use, but also what kind of org structures you need to effectively cater to the simulation requirements. Right. So this is an example where a central team that is connected to the different applications, so can leverage the learnings from different applications and different regions, and can apply any new capabilities that are developed across the machine integration space. So a team like this makes a lot of sense because this team caters to all the different types of applications that are shown on that slide below. So next we'll go into what types of simulations are used. And again, the focus is machine integration, right? So the Cummins product is now how it gets integrated into the end application. So we're doing a lot at machine level CFD simulations or computational fluid dynamic simulations. A recent focus area has been on external aerodynamics, so where we predict drag coefficients of vehicles and then also make recommendations on how their drag can be reduced, because that's directly translates to fuel savings. And then Neha talked about advanced controls features, right? So as markets go into platooning type of applications, there are again trade-offs of the distance between two trucks that impacts the cooling system performance. So then how does external aerodynamics interact with cooling systems? How does that interact with the distance between vehicles? So all of that, we are developing simulations capabilities to understand that. Another use case is multi-phase simulations, and this is typically hard to do. But we have found good use cases on, so things like if we have sensors that are exposed to the ambient, or maybe they are protected, but we are still having water ingress that can damage the sensors, right? So then how do we use our simulation tools to predict that there is a potential for water ingress, and so you design protect for that. or going back to cooling system performance, how do you ensure that whatever coolant you're filling, right, it kind of gets uniformly distributed in all the cooling channels and jackets so that you end up with an effective cooling performance. Diesel exhaust fluid, and again, the going back to the number of applications and regions our products go into. In very cold ambient conditions, there is, of course, a need to thaw your diesel exhaust fluid. Right. So then we are trying to see if simulation tools can help us predict that. The next piece is solid temperature prediction. So again, if you look at it from an integration standpoint, right, I put an engine on a commercial truck. The truck has been designed and our engine has been designed, but once it's integrated, there could be scenarios where you have hot air recirculating within the engine compartment, right? So how do you anticipate that? And then again, what's the right area to provide heat shields? Where do you need to provide outlets for that hot air to pass? And where do you see a risk of components overheating? Right, so that is what we do in solid temperature prediction. This next one is pretty standard. So pressure drop studies using CFD tools, but this is the earlier you do it, the more effective integration you'll have, because all of your plumbing or piping routing depends on this, right? So that how do you do it so that your vehicle packaging is considered, but at the same time, your powertrain requirements are also met. And then lastly, what we call underhood simulations. So it's basically studying the airflow again under the hood, right? So through the engine compartment or powertrain compartment. And this has many applications. So first is, of course, is the machine cooling system designed properly to meet the heat rejection requirements of your powertrain? So that's a obvious goal, but it has some added benefits as well, where you can now get better fuel economy if you can size the fan correctly. You can reduce the noise levels of your powertrain again if you do this integration well. So that's a quick snapshot of what we do in CFD. And now moving to structural dynamics. What you see in the middle is what a typical application will look like, right? So you have a Cummins engine that's driving an alternator and could be driving like a air compressor or a pump on the other side. And then you have connections between all of these. And then this entire structure gets mounted on either a platform or a frame, right? So when we talk about integrating this, there's one key area for torsional vibrations. So we have tools that translate an installation like the one shown here into a mass elastic 1D model. And then we analyze that to then select the right type of coupling for that application. It's also for marine applications. There are some certification requirements. So we have tools that will directly output a report that can be submitted to that regulatory authority. And just as we do driveline torsional vibrations, we also do a mounting system analysis. So what are the right types of isolators or mounts that need to be selected? Where should they be positioned? How can that be optimized, right? So that is what we do in mounting system analysis. Next would be what we call front-end accessory drive. So it's essentially your belt drive that drives all the different accessories. And again, we often have changes from our OEM partners that they want to use a bigger alternator, or their maybe loop pump is, or hydraulic pump is changing. And so what we try to do is we have a validated model for a base installation. And so when any of these changes happen, we can use our models to see if we need additional tensioners, is there a risk of belt slippage, those kind of things. And the power takeoff analysis is something similar. So when you're taking power out from the engine output, then you can see what will be the impact on the crank front end. You can do a sensitivity study of different hub loads or change of oil grade and so on. The next piece is, again, still in the structural space, but now we're talking about detailed 3D FEA models. So with our, if we take the example of an engine, then it will go into different applications, will be coupled to different types of transmissions. So then the design has to be such that it will be able to integrate with all of those transmissions, right? So then we do what we call a full powertrain structural analysis. The next piece is we often have requirements from, let's say, smaller OEMs or different regions where they require very specific tailored installations. And so there, then we would help them with the full installation. So everything related to how you lift the entire genset canopy, to how do you transport your powertrain, how resistant it will be to seismic loading, and so on. And if we go one more next, right? So what you see on the right is as we are seeing a lot of work happening in alternate powertrains as well, and Cummins is heavily invested into fuel cells and electrification technologies as well. So we are seeing these additional use cases for using these simulation tools. So while we will not own crash worthiness or crash certification for a vehicle, we are using these tools so that when we design our battery pack, or when we decide how it gets mounted on the vehicle, we go in with that understanding of, will it meet, let's say, a side impact scenario? What kind of acceleration levels will the battery pack see in that type of scenario? Again, now because we are dealing with high voltage systems, it's important to again look at electromagnetic interference and compliance at a system level, because that impacts how you would route your high voltage cabling, where do you place your power electronics devices, and so on. And with these new technologies, we are now working with different materials as well, right? So how do you analyze composite materials used in battery packs and so on? And this is I think the last slide. So we are calling it marketing CAD, but think of it more as design and packaging. So because seamless integration is the end focus, what we do is typically we provide our powertrain models to our partners, but we have a way of kind of masking the internals of it, but still giving the right model so that the space claim will be accurate. And then what we also do in the space, design and packaging space, is again, look at what is the CG location, how do the mounts need to be positioned based on that, fit checks. And then one recent capability we have developed is, and this is very useful for prototyping or repowering kind of projects, is if you start off with a scan of the installation or scan of certain components, we can create accurate models based on that. Yeah, so I think one common theme in the design space also is on automation. So there are ways to parameterize the space claim that you have across different applications and see how you can commonize, be it battery modules or other powertrain elements related to that. So a lot of work happening in this space as well. And yeah, so this is the last slide, the takeaway slide. So I think we talked a lot about simulations today. The big focus right now for us is firstly having that culture shift and truly doing simulations based product development. And what is the key enabler for that is picking the right tool for the right use case and doing it at the right stage of the program. And it's truly a company-wide effort, because simulation teams cannot do it by themselves, right? There is the right data that needs to be collected at the right phase that needs to feed into the simulation tools. The data itself needs to be of good quality so that the simulation results are more meaningful. So it's truly a company-wide effort, and we are engaging with every function in engineering to kind of embrace the simulations-based product development. And I think the benefits are huge, right? So it will help us innovate faster as we work with these new technologies. So and deliver more robust designs for our customers. Definitely will help to reduce our cycle times or development times. And what kind of resonates with me personally a lot is the environmental impact as well, right? So every time I help to avoid, let's say, a hardware test, right, we are burning less fuel. Every time we build a more robust product, we are extending the in-use life of that product. So there'll be less material use wastage at the end of it. So yeah, so huge benefits to be had, and we are truly engaged on moving to simulations-based product development. So I think we'll stop here, and if there are any questions, we'll be happy to take them.
Namita, we are done with our presentation.
Thank you, Neha. Thank you, Tejas. It was indeed very deep, insightful, and an interesting presentation. So we have a couple of questions from audience. So I'll just pick up them one by one and just put it forth. Maybe you can just take off the presentation.
Sure. How do I do that in WebEx? Stop sharing. Yeah.
So the first question is, if there is any guiding principle to optimize the extent of real-time precision of a simulation algorithm and its cost and processing time on implications and the implications in the system, towards the system.
So if I understand the question correctly, the question is more about how do we actually take a decision between the computational time and the accuracy of the simulation? Is that what question's essence is?
Yes, and then how it is optimized with
Okay, sure.
to the best to the extent of best real-time precision.
Right. So that's a very good question, actually, and that's a dilemma which all the modeling and simulation teams have it in their mind when they pick up a tool or they pick up a process. What we really need to understand is what is the purpose of the simulation. So if the purpose of the simulation is at a system level, we need to evaluate that what's the fuel economy, then I can live with a lower fidelity of my turbo and others, and then just see the impact piece of things. And if my purpose of the simulation is mostly onto a component level stress analysis, or if it is mostly about what should be the optimal turbo in this application, that's where I'm going to have the higher fidelity. The optimization of the tool versus the purpose is not something which we have as a ready-made solution. It is done as an iterative method, mostly keeping in mind that what is the impact of the simulation versus what all the efforts we are putting together. So that's the kind of a compromise which we come in. So all the system simulations are, that's why in a 1D domain, all the detailed stress analysis, safety analysis, and everything is in a finite element domain. So that's the kind of decisions which we have taken over our experience, but there's no optimization which we have done on the tools versus what needs to be done. Tejas, you want to add something?
The only thing I'll add is this is an ongoing process that truly needs engagement across teams, right? Because there'll be some use cases that you have proven are known, the tools are already capable. So those, it's just a matter of implementing them. There'll be others where the tool capability is in development or is not there yet. So for example, emissions modeling is very tough, right? The physics and the chemistry is involved. It's tough to do it in the modeling space. So you have to look at a combination of physics-based modeling and data-driven modeling to do it. But you have to, so wherever you're kind of developing these capabilities, right, there's a close engagement needed on what's the end goal, and then where do you need accuracy versus where do you need repeatability, right? So that lens is very important to have. And so again, to summarize, there'll be some things which are good to go. It's just a matter of deploying them. There are some which will need engagement between different functions. And there is a third lane, which is how do you keep on building capability, right? So there it's a matter of partnering with software suppliers on how do we get the tools to run faster? How do we get the tools to maybe run in parallel multiple cores on like a supercomputing cluster, right? So there is this capability swim lane that is kind of chugging along in parallel, and then you have to then deploy it thoughtfully.
Thank you. So the second question that has come is, the emission standards are actually moving from BS6 to BS8 and then ahead. So similarly, we'll have it for the machine road vehicles. It will move from BS4 to BS6 in the coming months. So how do you see simulation tools and data on analytics collaborate with each other to further meet the requirements of engines with these new emission compliance requirements, and also making it economically effective? And then if you could share some examples of such technology collaborations.
Okay, I'll again start first. So, and there is just add on top of it. Yes, there is going to be a journey in the emissions from BS6 to BS8 for on-highway and from BS4 to BS6 in off-highway domain, like it has been from BS4 to BS6 in an on-highway where we are today. And that's how we have achieved this with a big chemical factory which actually going to sit onto the vehicle itself, right? And then how are we, it's modeling and simulation has helped in that journey from BS4 to BS6 is to optimize the performance of those after treatment and see how does it actually help in the overall. When we move from BS6 to BS8, not only the optimization at a component level, not only at the vehicle level would be important, we need to also understand the duty cycles, the scenarios where these simulations are going to happen. And we need to actually do on-the-air programming. We need to actually look at diagnostics and prognostics of these components which are going to run and flee. Different types of applications will guide for different types of optimization, because the prediction accuracy level will start getting narrower to narrower, because you're going to take controlled decisions out of those. So that's where the team is working on to increasing the fidelity of the models. Earlier, we were not predicting, say, NOx. Now we're predicting NOx in the BS6 domain. We'll go towards carbon dioxide, particulate matters. So all of these simulation capabilities, what Tejas was mentioning, the capability is getting developed at a component level and now integrating at a vehicle level to see how it is going to impact at a system level performance. And the control strategies will evolve from doing a closed loop at component at a system level on the fly for different duty cycles to meet those emission requirements. And we need to have those tools and processes ready to complement those design and development of those products. And that's how Cummins is working today.
So just to add, so I think specifically on how data analytics will link to simulations, right? So one immediate use case that I talked about earlier was wherever your modeling is limited by what physics you can simulate, right? And the more complex your system becomes, the harder it is to incorporate all physics and still get the model to run fast enough, right? So there you'll definitely see opportunities to collaborate between using machine learning or a data-driven model and a physics-based model, and then using them together. So coupling them together so that it's almost like a hybrid model, right? So that's a very specific use case. So the more complex systems you work with, you have to find that collaboration between a data-driven model and a physics-based model. So that's one. Second is, as we see more data flow in from the fields, so I think with telematics and all the data that is flowing back in, that will give us a better understanding of how our customers are using the applications, right? So now there is an opportunity to tailor your products to specific customers. Then it will also give you an idea of how your products are aging over time. So that aging information is again something that you can feed into your models, so that now you're able to simulate not just the start of life, but the performance at the end of life of the product as well. So yeah, I see a lot of use cases in combining analytics with simulations, and they'll in fact become necessary as the complexity of the systems go up.
And that leads to a digital twin kind of an environment, right? When we'll have actually digital twins, which will be a combo of physics-based model and a data-driven model, and run real time with your product so that you can take a real-time decisions.
Thank you. That's useful. Okay, so there is another question from the audience, which says that what are the two most important components or factors in terms of increased competitiveness and transition to simulation-based product design? Basically, the two important factors which will help drive increased competitiveness and the industry transition to this simulation.
So I just want to go first now.
Sure. So,
I'll have my two picks.
So I think we tried to summarize it on the last slide. So one is picking the right tool for the right use case. You will rarely have a tool that is perfect for all use cases, right? So picking the tool for that specific use case. And I think the computing power increasing, simulation tools getting better, AI and machine learning becoming part of simulation tools. So these, I think, are pathways which will kind of grow on their own, right? So just making sure that you tap into them and then pick the right tool for the right use case is one. And second is, which I can't talk enough about, is the culture change, right? Where you truly need engagement. It's not a role of simulation teams to kind of deliver on simulations. They'll not be able to do that by their own, right? So truly engagement from all functions, and maybe it starts with a leadership top-down approach, right? Where you kind of mandate that you are at every stage or every element of work that you do, you have to consider how simulations can help. right? So that type of culture change, and again, I think that engagement is needed from both sides, right? So I come from a simulations community, so maybe I'm too optimistic about simulation capabilities, right? But we see the other end of the spectrum as well, of people who have kind of worked on hardware all their life. They are kind of, they say that I'll not look at the simulation tools until it's within 2% of my real system, right? So that 2% makes sense for maybe a small set of use cases, but there's a big set of use cases where repeatability and the accuracy levels where you're at today, the tools can be used, right? So that culture change and then picking the right tool for the right use case, I think would be the two biggest enablers for competitiveness.
I'll just reverse the order. Like I'll put cultural change as the first one, predominant, because me and Tejas, when we started, we know how much of a resistance it was, that, how much accuracy we need to have and all sorts sort of things. So yes, definitely cultural change from a simulation integration is very, very important. We really need to understand how can we use the current ones. And the second one is definitely complementing the tools each other. Like, there've been of late, whether the FEA is the right tool for this or something is right tool for that. No, we need to complement all of those together and then create a process of things. We actually pay a lot of attention nowadays in modeling and simulation on the tools, right? If you go to the hiring market scenario, you'll say so-and-so is a MATLAB person, so-and-so is a ANSYS person. No, that's not what defines us. It's a process. The moment these tools starts complementing each other and the entire product life cycles becomes a process, that's where you actually achieve the nirvana of modeling and simulation, or a simulation-based product development.
Thank you. So another question is, what is the best way to evaluate and address uncertainties which are there in the real-time situation during the early development stage of simulation? So how is that best evaluated and addressed at the early stage itself?
So there I'll use the old school methods, right, from the Six Sigma approach, right? So have what is your desired output of that component at test? Define your noise factors. How much is available to you, right? So uncertainties by definition is something which is not known, which is not defined yet. But whatever kind of uncertainties you've seen in past and have experienced it, at least start bucketizing them. Define their limits where you are, sure of what kind of limits your product is going to see that. And then start using simulation to evaluate the performance in the presence of these uncertainties. I come from an aerospace background, and there was one bottom line for all of us when we develop any control strategy. Your hardware can fail, but your software cannot fail at any given point of time. So simulate all kind of extreme scenarios and make sure that your software stays. And so it goes for the hardware as well, right? So when we are looking at the uncertainties, define your noise factors known to you. Expose your simulations, expose your models to all those uncertainties, add 10% more margins to it, and see whether you are able to meet those uncertainties or not. And once that's done, if you remember the V diagram which I started with, the model repository, the learnings has to be shared across the community. So if you see an uncertain behavior which is not being captured earlier, that has to be documented, and that has to be becoming a part and parcel of the next baseline product which we are going to pick up. So the only way to handle uncertainties is bucketizing them, putting up a range around it, whatever is known to us, and then exposing your modeling and simulation tools towards it. Sometimes what happens is even your models are not capable of handling those uncertainties. Then you need to actually build the capability of your model to handle the uncertainties. Let's say my model is not capable of handling the altitude because it's just not sensitive to it. Then I really need to build a model which is sensitive to the altitude variations, and then do the simulations around it. So it's a journey. The more you learn about the uncertainties, start including in your test scenarios, start including in your models, and then build on top of
it. Yeah, thanks. And one last question is, could you please throw some light on analysis-led design as a systematic approach rather than just a conventional product development approach?
Well, I mean, me and Tejas can go on again on lens around it. Definitely, it has to be done as a systematic, product development. We've been talking about it, integrating as a V diagram. There's definitely no two ways, there's no another approach than the systematic approach towards it. You need to develop a W diagram, if I can call it. There's a V, and then inside that V, you have to have a V of modeling and simulation. So right from the requirements as a model-based system engineering, you need to start modeling your requirements. You start building your components. You start integrating your models so that you start looking like a system. So definitely it's a systematic approach. The moment you start doing it as a just a check mark, or if you start doing it that, okay, I've done a design and I'm going to, in a retrospection, look at how does it fare. That's also good, but that's actually an old school way of looking at modeling and simulation. The new way of looking at it is that you also develop model like you're developing a product. So when you actually hand over a product from one cross-functional team to the other, or when you hand over from your organization to the end customer, you're also handling a model, or you're ready with that model that at some point of time, that is a digital twin which sits with you and you are able to duplicate the issues around it. So there is definitely no two ways in the newer product development cycles that it cannot be ad hoc. It has to be systematic. It starts from the requirements and it has to end at the validation of the requirements where the end customers is happy with that integration. So that's why Cummins is putting a lot of effort and innovation efforts around building the capabilities right from the component to the system level, and also taking one step ahead and saying that I'm going to do virtual integration also, so that I'll let you know that how the performance is going to be in an integrated installation. Tejas, you want to add something?
Yeah, the only thing I'll add is, so what Neha talked about is how do you define the process, right? What is the right process to have? And because this will likely be a change for many companies, right? So it's also important that you kind of abstract out the or have the right tracking mechanism to see how the change is happening, and then what is the impact of that change. So what we have found useful is if you can put some thought around what are the key indicators of how the entire organization is adopting simulations, right? So once you have defined your W diagram, then how effectively is that being adopted? How effectively is your organization getting better at understanding simulations and simulation tools? And finally, what is the impact of that adoption? So if you can develop some thoughtful metrics around it, which are visible to leadership, right? That also helps to, first, you have an established process. How do you then make it sustain, right? So that would be the key for that change.
Thank you. So these were the questions that we had from the audience. So I would once again thank you, big thanks to both Neha, you and Tejas. It was indeed a very, very informative and an interesting session. Thank you for joining. And we have our next Tech Talk beginning at 12 noon. So we would request audience to stay logged on to Hive. Thank you. Thanks, Neha. Thank you, Tejas.
Thank you, everyone.
Thank you. Thanks for the opportunity.
Thank you, Dr. Anuradha. Thank you.
Thank you so much. My pleasure.
Thank you.
At Ashok Leyland, we've been in the business of mobility for close to 70 years. We are a part of the Hinduja Group, a transnational conglomerate spread over 100 countries and 6 continents, with diversified business holdings across 10 verticals. Today, we are the second largest manufacturer of commercial vehicles in India. We are the third largest manufacturer of buses worldwide. We are present in more than 50 countries, besides being market leaders for buses in Sri Lanka and Bangladesh. We have a significant presence in the countries of the Gulf Cooperative Council and Africa, dominating in the bus and truck segments. Our products reach out to over 70 million people. Yet every day, we strive to find new ways of enhancing the lives of the people around us. We're constantly innovating for the future, helping redefine mobility, designing better products, and finding better ways to produce them. Our products are defined by their practicality and functionality. Every customer solution we provide is driven by thoughtful innovation. With the introduction of BS6, Ashok Leyland has taken the proven IEGR technology up a notch to introduce the iGen 6 engine technology, which enhances the engine performance and durability further. With lower diesel exhaust fluid DEF consumption and compact design, iGen 6 lowers the cost of operation, offers better fluid efficiency and low maintenance. The unique mid-knock strategy ensures overall lower cost of ownership. Avatar is a revolutionary, industry-first modular truck platform from Ashok Leyland that is powered by the iGen 6 technology. Avatar's incredibly diverse range of options lets you customize your truck based on your load, terrain, and application requirements, spread across the entire range from 18.5 to 55 tons. The Avatar range of trucks comes with multiple options of axle configuration, loading spans, cabins, suspension, and drivetrains on a single platform that offers you a whole new trucking experience. Our vehicles serve our customers in remote locations, and we ensure that every vehicle is fitted with monitors that track its vital parameters. With an early warning system, we make sure no one is left stranded. The joy of children using our product inspires us. Innovations in our school buses have always kept children's needs in mind. We also make sure that they are the safest buses on the road. We are working towards using cleaner energy sources to drive our vehicles. Our electric vehicle program is set to redefine the future of environment-friendly transportation. Our greatest test, however, is a matter of national security. We are the largest supplier of logistics vehicles to the Indian Army. Our vehicles perform under the toughest conditions on our national borders. Our engines not only help safeguard our nation, but also help power businesses. The power solutions we provide are amongst the most reliable in the market. Our belief in partnership for growth has kept customers' progress at the heart of every solution we provide. To us, partnerships happen on many levels. Our driver training institutes have produced close to 1 million highly skilled drivers across the country. In the remotest villages of India, we have revolutionized the way children are being educated. Through key collaborations and innovative teaching methods, we are empowering the children of our villages. To us, mobility is more than just the business we are in. In our world, it signifies progress. It means enabling success to our customers, enhancing their lives. Mobility for us is everything in life.
In this shifting, driven world, the one thing you can be sure of is change. It's tough to stay ahead, but that's okay, just as long as you always know who to count on. We are Cummins. We create the power solutions people depend on. It's what we've done for more than 100 years. Sure, all that history makes us proud, but the future pulls us forward. However good we are today, we know the best is yet to come. Our business is endlessly shaped by our customers. What they need defines us. And what they say makes us stronger. Who are they? Everybody. But whether their challenges are personal or global, we do everything in our power to solve them. Because no matter where you're headed, we've got your back. And we're with you all the way. And we never forget how our actions impact the people and the world around us. So whenever there are choices, we make sure we do the right thing. This is what we do to power a more prosperous world. And that is never going to change. That's why we're always trusted, always innovating, always customer-driven, always responsible. For a world that's always on.
Welcome to the world of Tata Steel, a flagship company of the global business conglomerate, the Tata Group. Tata Steel is one of the world's most geographically diversified steel producers, with operations and commercial presence across the world. The story began with the dream of one man, Jamsetji Nusserwanji Tata, a pioneer, a visionary, a man ahead of his times. He had his heart set on building a steel plant in India that would compare with the best globally. His dream was brought to fruition by his son, Dorabji Tata, and thus was born Tata Iron and Steel in Jamshedpur in 1907. At the turn of the 21st century, fueled by its global aspirations, Tata Steel expanded its footprint to Southeast Asia, in Singapore and Thailand. Acquisition of Chorus in Europe in 2007 placed it amongst the top global steel companies in the world. In 2015, Tata Steel set up a state-of-the-art integrated steel plant at Kalinganagar, Odisha, in India. The Phase 2 expansion of Kalinganagar steel plant from 3 million TPA to 8 million TPA is currently underway. The company is all set to pursue domestic growth with its acquisition of Bhushan Steel Limited and the steel business of Usha Martin. This forms part of the overall strategy to increase its India footprint, build capacity in long products, and enrich the product portfolio. Besides steel manufacturing facilities, the company has mining assets in the state of Jharkhand and Odisha in India. Tata Steel has evolved into a leading steel manufacturer, catering to diverse market segments. In its trend-setting journey, spanning more than a century, Tata Steel has contributed immensely towards the well-being of the planet and people. Guided by its vision to be the global steel industry benchmark for value creation and corporate citizenship, Tata Steel is poised to lead the future.
At Bharat Forge Limited, we don't believe in pause buttons. 50 years ago, we hit play, and we haven't stopped since. We move, we go places, and we take our legacy with us. We started small, but our dreams were big. And we chased them tirelessly with all our heart. That's what brought us to the top. To the world's biggest names. And to people's lives. We're committed to partnering greatness, no matter where we go. From India to Germany, to France to Sweden, and now USA. We always go that extra mile and bring the best to wherever our clients are. And we never settle. Over 50 years, we have pioneered innovations across fields. Our expertise keeps sharpening. Our credits keep increasing. And our relationships, they only keep growing. We are fueled by our dreams. Inspired by the next possibility. We nurture ideas, give them wings, make them soar. We seek to build a better, smarter, and brighter tomorrow. And we will. Because that's just who we are. Driven, caring, innovative, and unstoppable.
At Ashok Leyland, we've been in the business of mobility for close to 70 years. We are a part of the Hinduja Group, a transnational conglomerate spread over 100 countries and 6 continents, with diversified business holdings across 10 verticals. Today, we are the second largest manufacturer of commercial vehicles in India. We are the third largest manufacturer of buses worldwide. We are present in more than 50 countries, besides being market leaders for buses in Sri Lanka and Bangladesh. We have a significant presence in the countries of the Gulf Cooperative Council and Africa, dominating in the bus and truck segments. Our products reach out to over 70 million people. Yet every day, we strive to find new ways of enhancing the lives of the people around us. We're constantly innovating for the future, helping redefine mobility, designing better products, and finding better ways to produce them. Our products are defined by their practicality and functionality. Every customer solution we provide is driven by thoughtful innovation. With the introduction of BS6, Ashok Leyland has taken the proven IEGR technology up a notch to introduce the iGen 6 engine technology, which enhances the engine performance and durability further. With lower diesel exhaust fluid DEF consumption and compact design, iGen 6 lowers the cost of operation, offers better fluid efficiency and low maintenance. The unique mid-knock strategy ensures overall lower cost of ownership. Avatar is a revolutionary, industry-first modular truck platform from Ashok Leyland that is powered by the iGen 6 technology. Avatar's incredibly diverse range of options lets you customize your truck based on your load, terrain, and application requirements, spread across the entire range from 18.5 to 55 tons. The Avatar range of trucks comes with multiple options of axle configuration, loading spans, cabins, suspension, and drivetrains on a single platform that offers you a whole new trucking experience. Our vehicles serve our customers in remote locations, and we ensure that every vehicle is fitted with monitors that track its vital parameters. With an early warning system, we make sure no one is left stranded. The joy of children using our product inspires us. Innovations in our school buses have always kept children's needs in mind. We also make sure that they are the safest buses on the road. We are working towards using cleaner energy sources to drive our vehicles. Our electric vehicle program is set to redefine the future of environment-friendly transportation. Our greatest test, however, is a matter of national security. We are the largest supplier of logistics vehicles to the Indian Army. Our vehicles perform under the toughest conditions on our national borders. Our engines not only help safeguard our nation, but also help power businesses. The power solutions we provide are amongst the most reliable in the market. Our belief in partnership for growth has kept customers' progress at the heart of every solution we provide. To us, partnerships happen on many levels. Our driver training institutes have produced close to 1 million highly skilled drivers across the country. In the remotest villages of India, we have revolutionized the way children are being educated. Through key collaborations and innovative teaching methods, we are empowering the children of our villages. To us, mobility is more than just the business we are in. In our world, it's
I'll be presenting. So I'm there I just joined. You can see me there. I do. Hi, Dr. Ashish. Good morning. Hi, Namita. Good morning. Hi, Namita ji.
Yes, good afternoon, Mr.
Good
Tito.
afternoon.
We'll just start in a minute
Sure.
at sharp 12. May we start, Mr. Tito? Should we? You are muted.
Shall I share my screen?
No, just give me a second. I'll just give a brief introduction and
Sure.
then.
Sure.
So, good afternoon, all. We welcome you all to a tech talk on innovative past with inventions using structured innovation methods of TRIZ. Our esteemed speaker for this session is Mr. Tito Kishan Vemuri, who is founder and CEO of ProInn Consultancy and founder chairman of ATTI, India's Regional Matriz Association, and director of TRIZ deployment of Matriz in India. With 25 plus years of corporate experience in technical innovation, operational excellence, and organizational change, Mr. Kishan has facilitated 1,000 plus inventions. He has been able to achieve millions of USD savings over the last 15 years using the structured innovation methods of TRIZ to various clients. So we look forward to hearing from you, Mr. Tito. Over to you, please.
Thank you.
Thank
I will share my screen.
Yes, sure.
Do you see my screen, Amita?
Yes, we
Okay.
can. You can just
Thank
put
you.
it in screen. Yeah.
Sure.
thank you.
So good afternoon, all. Thank you. It's a privilege to be here and talk about something very important in the context of Global Innovation Index. I'm a TRIZ Level 3 practitioner and a certified Master Black Belt from GE. Okay, so this is what I would like to take you through on inventive thinking with a case study. As Namita just talked about, I'm actually a member of CEM or Matriz, that is called Council for Expertise, and I'm one of the 20 people across the world. I'm a member of CII National Committee for Innovation and Technology since 2018 and a management committee of SAE. So I have been had a unique opportunity to lead innovation in one of the most innovative companies in the world on energy domain, and could able to enable close to 1,000 inventions there. So what we do is I teach how to develop differentiated solutions. We actually make it practically applied through facilitation on real problems and develop differentiated solutions. I coach the innovation leaders in the organizations on how to build innovation culture, and we consult. I have been recipient of Tech Acharya from Mahindra. This is a recognition where I've been recognized as the Director of TRIZ deployment of Matriz. And I have a unique opportunity of giving a keynote talks on TRIZ in Asia, only Indian. And I've been a jury for CII National Industrial Innovation Awards. A couple of people, the best minds in India and abroad, I work with them and actually facilitate a new thinking and a new feather in their cap on thinking. Just to put that in the right context here, if you look at this methodology of TRIZ, it actually adds immense value. And as you can look at, this is where I took it from my mentor, Dr. Sergey, who's a TRIZ master. If you look at the brand value of an organization and the patent capability that it does. And essentially, TRIZ gives you a very strong intellectual property generation and a practical application. So you can see a significant trend where the TRIZ deployment has started and then a significant jump in the brand value. Another example I can quote is coming from Hyundai, where the TRIZ deployment started and then where you can see the brand value of the organization going up. The context is when we're talking about the deployment of TRIZ, it actually adds immense value with strong intellectual property and very importantly, we get practical novel solutions. So to put the context here, if I say that how India can be a next innovation factory. Okay, traditionally, if you look at our country post-independence, we have been a recipient. Majority of the time we had paid royalty for the technology. Either you look at the East or the West. And now what I look at is the need and the requirement is how you can able to be providing innovative solutions to the world from India. And that means that you need to really create and then you need to supply. So that I see as a switch. If you can able to work that switch, if you can switch it on, you can able to generate something quite interesting. And how we can make it by two things. We can make it by adapting inventive thinking, that's the TRIZ methodology. And very critically, we need to have a change mindsets. By doing so, you can able to do it across the government, the corporations, the MSME, startups, and academia. And we have significant need across the country. So if I were to look at the Global Innovation Index and India starting at gone up much higher at 46. One of the important point I see there are two areas where we see there's a significant boost that is required. And one thing talks about the knowledge and technology outputs. And if I were to look at the particular points in which it is being evaluated, it brings a very interesting insight that the amount of patent capability and the exports driven for intellectual property is a significant delta that is still as a gap in the country. And in 2018, I've been talking about this since 2018. I looked at the population and I normalized the patents that are granted, and the links are there from where I took the source. And if I were to look at this normalization, number of patents per million population, from 2009 till 2017, you can see the US has been consistently at a higher level. And what is interesting is you can look at China has a significant evolution in the last decade. And what is an opportunity? We just moved twofold. And I see that opportunity for us as a country is to improve 100-fold, which means it's important that we need to bring something more concrete that can give us the foundation to scale up. And the case in universities, as you look at, there's a significant element of gap in the universities. And I do understand that IITs are quite significant, very well known, absolutely. But when you look at the top 100 institutes, it's something which we need to really scale up. So if this were to be put as a context, and GI being the entire event, I thought it would be very relevant of what I'm going to talk about and how you can able to bring structured innovation that can able to give more inventions, high quality inventions and strong patents. And this basically sums up that our thinking at this point of time should be quite different. And that's where the inventive thinking brings us. So in my last 15 years, I've been working with large corporations. And what I've seen is the 5 unique things that companies would like to protect as a solution. And this 5, I call them as 5 growth vectors. And people want to reduce cost. This is a global requirement, not just for India. Performance is only way you can able to compete with anywhere in the global world. And complexity breeds problems, so you need to have simplified solutions. And in the context of where we are in the pandemic, the security is very important, paramount. And you need to talk about the bottom line of the solutions that people provide is where we need to enhance. And very critically, everyone is taking Mother Earth for granted. So you need to come with solutions that actually reduce environmental impact. And what I've seen, my experience in the last 15 years, is we can able to apply this learning channelized to different particular outcomes, be it on new technology, new products, or enhanced products, even digital products, or even getting into new markets. So to just summarize this entire thing, this methodology of TRIZ is quite fascinating. It's called, if I were to put it in a word, the best smart moves of all the innovators around the world, if you can able to put it in one place, that's where this methodology comes from. So this is a methodology which is derived from patents. So that's the best database that is available for novelty. So the father of TRIZ, his name is Heinrich Altschuler. And when he talked about looking at patents, he found that problems and solutions are being repeated across industries, which means to say that we don't need to reinvent the wheel to solve a problem. And technology leadership comes only when you have a culture of innovation. And what we do is we make innovation as a sport and make people play it and win. And very critically, people think many a time it's very impossible to solve problems. And the most impossible problems many a time are nothing but having two conflicting requirements. And if we can able to come with a win-win solution, that's where we can able to give a powerful solution that which many a time people think is impossible. And in the context of pandemic, it's very critical that people need to develop more products in a given time. And one of the biggest challenge many corporations face is the time that they take to innovate. Because many a time people use the known methods of trial and error, which actually makes the entire process quite long. And very critically, unless and until we groom our people from engineers to innovators, it would still be very tough. You groom, you empower your people, and you can demand things from them. So General Alshuler, he's the father of TRIZ. This TRIZ methodology, people say that everyone knows that because it's been there for 7 decades. What people know is quite limited, and what we has evolved is quite significant, which I'm going to talk about it, and I'll show a case study as well. So traditionally, this method started from patents. So what Alshuler developed, he developed solutions. He developed tools that can help us to solve problems. So as you look at it, this entire methodology started as a solution toolkit method. But what is more critical is not just the solution, because the entire R&D, if you look at, is all about identifying the right problem to solve, which means that is the most critical part. And how do you do that? And we have very fascinating tools that can help us to identify what are the right problems that need to be identified to be solved. And very critically, if you look at, it's not just identifying problems. Now, if you come with solutions which are not practically applicable and takes a long time, probably your company can wait, but the industry would not wait. So our charter is to come with practical solutions that can be done very quickly. So that's where we have set of tools that can help us to come with practical application very quickly. And very importantly, in the context of expanded innovation domain around the world, with the massive information of internet being around, what is very critical is how you can able to make big swings. And that big swings comes with understanding of the main parameter of value, which I'm going to talk about it just now. So before I get into this main parameter of value, I think it's very critical to understand what is the language of innovation. Because many a time, if I were to talk about a programming in Java, what I would do, I need to learn programming in Java or in C or C++. And that's true for everyone. So which means to say that if I have a knowledge of programming, then I can able to program. And in the context, everyone talks about innovation, and that is a very exploited word without real outcomes that people bring on. Now, when you talk about language of innovation, people talk about creativity, people talk about need and all those things, but that actually changes from person to person. So again, going back with programming in Java, anyone who understands Java can write a program. So when we talk about innovation as a language, this is very interesting. If you look at it, if you look from this one to here, from the phone that actually started from the Graham Bell to the time where we are, it's a device used to communicate. But very interestingly, now people not just use to communicate, people can use it to take selfies. So the new parameters of value that essentially start adding up. And in the context here, there's a neem stick, as you see here, and to the point of automated toothbrush. This is a 600 rupee solution, and this is just a 1 rupee solution. But if you look at functional understanding, they're same. What we are talking about is we are trying to pamper the person, making the person more lazy, and that's why we are able to interested to pay more value for that. But if you look at it, fundamentally, the point is the functions remain. It doesn't change, but the solutions change. The intellectual property resides in the solution. So if you're talking about mastering the art of innovation, one of the very fundamental things that one has to understand and master is the mastering the art of understanding functionality. So anything that I'm going to talk about further, even in the case study, I would be showcasing how that functionality becomes a paramount understanding and the method, how it actually brings a solid framework to do that. So the main parameter of value is where when you talk about this, it's what people are willing to pay for. And that's why they're trying to differentiate. It's well understood in the market, and people would like to have that as a solution. Now, that's what is still a gap of unsatisfaction being there. But there's a parameter of value which is already known. For example, if I'm talking about automobile, the safety of automobile is always an important requirement. People purchase understood, and it's been addressed. The other aspect is you get to the tacit part, which is basically talking about in the context of the automobile. It's all about driving. It's all about a person's ability to do. And what is very critical is what is not expressed, and that we call it as a latent parameter of value, and it's still unsatisfied. So if you look at automobile as a engineering system, what we are talking about is the fact that people know safety is a main parameter of value. There are ABS, seat belt, and then airbags are pretty much there. What we are talking about is every time what we people look is all about a reactive mode, and all these approaches are all reactive. And can we go a proactive method is something which would be looking. And many a time people see looking into within the car, but can you go beyond the car? Can we provide solutions beyond the car? So that which is not expressed and not satisfied yet is where an NPV, and that is something if we can able to address, that gives a significant outcome in the entire evolution. So to addressing this MPV, so I would actually bring a very interesting, important understanding corollary with how to look at an MPV in its evolution. One of the very important aspects people talk about in B school as well is the curve called S curve. And the S curve originated fundamentally coming from the nature from the bacteria, where the colonies of bacteria start small, grow rapidly, and then mature at point of time and then die down. And that is true for every OEM. Every product that someone brings into the market, there's a point of starting and there's a point of life ending. So now when you look at this entire life cycle and put that in the context of innovations and inventions, your level of inventions would be very high at this level. And then it will, as the system goes up in its evolution, the level of quality of inventions would come down, and there are a lot more incremental innovations going up. But what is very critical here, if you want to look at the very parameter of ratio is of interest for us. What is that ratio? That ratio is the ratio of the functionality. That's nothing but the value that we are trying to provide over the cost. So what is interesting to see, this ratio changes at each phase of evolution. At the initial phase, when you look in, the value is very high. That is the reason why someone is trying to bring a product out. Once the product comes into the market, once people are adapting it, people are willing to put more functional value to it, and people are willing to pay more money to it. At a point of time where people would still, you would never see a product being sold which has inferior value than what it is in the past. So what you would see all the time, the value, the numerator, people try to enhance it. And what they do, they try to constrain or control the denominator. At a point comes where they try to reduce the denominator, and finally it becomes a commodity part. So if you look at this particular point, this cycle, we call it as adaptation, rapid growth, stabilization or maturity, and then death. What is very critical, if you look at every industry in the technology standpoint, and we are talking about technology here, and where we are talking about developing differentiated solutions with strong intellectual property. And as an example, if you look at the cathode ray tube to the LCD to the OLED and to the TV OLED going up. And now if you look at this evolution, each one itself is an S curve. And the S curve is all about the next evolution of technology. So I would actually make a strong recommendation for those who are interested to read S curve, where along with Dr. Shankar Venugopal, we written an article, a series of articles talking about how to craft an automobile new product innovation strategy using TRIZ. It's there in the Mobility magazine, Mobility Engineering, which can be looked in. Connecting this trends of engineering system, the S curve, I'm going to talk about the next one. So these three are very fundamental. You have a main parameter of value that you look at as an evolution on its S curve. And now these trends basically help us to really make that S curve in the path of the MPV at a much faster pace. When Alshira looked into one of the most successful products, he found that there are very interesting trends which are very consistent. So the mother of all trend comes from the S curve. And very critically, the main trend is all about increasing value. That is nothing but our numerator. That's nothing but the functionality. And now that functionality can be enhanced by looking into multiple trends. And multiple trends actually can help us to talk about what could be the next evolution that can be. And if you're talking about developing intellectual property, developing a strong new novel products, or either be a digital or a physical one, what is very critical is to understand what the evolution of trends is. And we can able to formulate problems looking at the trends and come with solutions much faster. And trust me, what we are talking about is all practical, novel solutions that are there in the field. So just to give you a context of this particular trend, I thought I'll take one interesting trend, and they're called trend of increasing system completeness. Very critically, you take any particular product, there's something called four important aspects of it. There's something called an operating agent. I'm actually using a Microsoft pen. The agent is basically the ink, which is the tip. Okay. There's a mechanism that you can see, which is out there, which basically holds everything. And now this is a battery, so there's an energy source, and there's a control system. At this point of time, control is with me. If you look at particular product and its evolution, so let's take, for example, as a pen, the marker. Okay, so the operating agent is ink. Now, if you look at the evolution of the product, now the transmission is being added to the operating agent, and you got a product called marker. Okay. Now, the next level, and this is the best level. See, from last 25 years, since I did my master's, I've not seen any significant innovations in your marker, which means the product at this particular point of time is there at that level for the last 25 years. Now you got this pen, which is about 9,900 rupees. This is about just 25 or 30 rupees, for example. Now, what you can do, you can able to talk about the energy source. It has an energy source, but still it doesn't have control. I still need to exercise my control, and it doesn't have the full energy. So the point here is, when we are talking about developing systems that are of high premium, and that's where we as a country, India as a country, should evolve, where you can able to generate premium products and charge a premium. And that premium product comes with the very fact that you need to bring a control system into it. So when we are talking about the best product which is available, which is multifold cost, is only just doesn't have just still have an energy source, but at the end of it, it still needs my hand. It doesn't have any other energy source than to write, but to write it by itself. So the best products in the market that you see are those products which we need to look at evolving control system being built into the system. So when we develop solutions where the system has an operating agent, you have a transmission, you have an energy source, and you have a control system, that's where we are bringing quite powerful solutions that are quite premium and very valuable to the people. So in the context of where we are in a pandemic, and obviously I'm sure everyone lived the last 18 months with mask. Obviously, since I'm at my home, I'm not using my mask, but absolutely I would wear mask. But look at this mask. To put the context of how we can able to come with novel solutions without much difficulty is what I'm talking about. What is very unique of this approach is we can able to model problems in quite unique ways. Look at this. If I were to use an N95 mask, obviously I can able to shield the virus. But the problem is the amount of oxygen intake or the air intake comes down, or you can able to, people can't see your smile. See? So there is an element of benefit and there's an element of penalty. And one of the very critical understanding of this entire approach and inventive thinking is one which has two conflicting requirements. There is a benefit and there is a penalty. The win-lose solutions are those which actually give benefit, but they still live with penalty. For example, we are talking about BS6 migration. The BS6 is a significant evolution. Now, if you look at the benefit is the entire emissions has come down, but the penalty is it's very expensive. Everyone has to increase their prices and everyone has to pay more money for it. So can we able to bring a solution with less penalty? It's a win-win. That is what this approach of problem solving is all about. And how I can do that, I'm going to show you that. There are about 5 methods, very unique way we can able to model mechanical perspective. A civil would look at civil, a thermal would look at thermal, aerothermal would look at aerothermal, a biological system would look from a biological standpoint. A chemical would be seen from chemical. But when we are talking about a system which has multiple disciplines interrelated, how do you solve problems? That's where the core of this problem solving comes in. So what we have very interesting 5 things. As I said, the language of innovation is functionality. We would be actually looking at a very powerful tool called function-oriented search, where we look outside and we adapt solutions from outside and formulate secondary problems and solve it. For example, if I were talking about shielding the virus, I would look at in aircraft engine and see how the best shielding is done, and I would able to leverage that and see what I can do. That's the leveraging of the solution. The problem here in this contradiction at a system level, if we wear a mask, then N95 mask, for example, we can able to shield virus, but the amount of oxygen intake comes down. That's a penalty. So I have a penalty here and I have a benefit, and that's a win-lose. You can able to come with solution. I can able to formulate a problem at a parameter level. A contradiction at a parameter level. And then we have very interesting called substance field modeling, where you can able to model in 76 standard ways. And very interestingly, we have methodology called ARIES. In ARIES, what we do, we look at the resources that are available and we solve problems, the most toughest ones. And that's why we have a registered trademark called structured jugaad. The spirit of jugaad is to use resources, but since it doesn't have a structure to it, it is not repeatable nor reproducible. That's the reason why you don't see outcomes coming in. But when you use the structure of TRIZ as a structure, we have powerful outcomes. And in ARIES, we talk about using resources and solving problems. So just to put that in the context of what this approach of problem solving is, I mean, from working in the aviation domain for long and in mechanical domain, if you talk about aircraft engine, one of the very important thing is weight matters. So the entire goal is to reduce weight. So what I can do, I can take an action. I can make the blade hollow. By doing so, I can able to reduce the weight. But the problem is the strength of the blade can be compromised. So as I said, someone has already solved our problem. The traditional approach is you try to jump onto a solution, but I said that someone already solved a problem. So what you need to do, there's an algorithm that gives in. So everything that we bring has a very strong algorithm of proven methods that can be used. So we have parameters, which I'm going to talk about here, the 39 engineering parameters, which are at conflicting requirements. As I said, the benefit and the penalty. One of them could be a benefit, one of them could be a penalty. And very interestingly, after Altshuler led about close to 20,000 patents in 1950s, and he found that there's just only 40 inventive principles. That's it. And if you can able to adapt the principles, and this is the metrics which I talked about, and what I'm trying to do, I'm basically trying to reduce the weight of the moving object, nothing but the blade, by making it hollow, but the strength is a penalty. So what it gives me a set of principles. So I would actually use these principles as guides to ideate, and I do the brainstorming session. And one thing it says that I can use substitute fields. I can replace with a mechanical, it's a mechanical link at this point of time. I can get to an electromagnetic field. I can use composite materials. If you look at one of the best known solution out there is a composite blade, which talks about how you can able to have a blade of low weight and having a most powerful reliability out there. So we use this approach even for software patents. If you look at the software, this is a patent which I'm talking about, which has been granted. So if you're talking about a file in the context of pandemic, encryption security is very important. So if you talk about this, if the file is encrypted, then what you can do, you can make sure that unauthorized access is not given. But the problem is if the file size is too big, it takes a little longer time. So what you do, I have a specific problem, I make it a generic problem, I find a generic solution, and I try to come with ideate and come with. It's quite interesting. It says that I use dynamization and I use segmentation. So if I can look at the entire file, I can able to segment them into context of data, context of images, of tables or text. What I can do, I can dynamize. Dynamization means having more than one. What it means, I can, instead of using one algorithm, I can use multiple algorithms. And absolutely, there's a solution is provided in that. So what TRIZ gives you is the directions of solution. It doesn't tell you how to code, and it doesn't tell you how to engineer. So these are engineering, and coding is something which is taken for granted. And what we are talking about is developing solutions to the problems. So I would like to talk about innovation strategies here, and I'll go quickly to the case study. So what we do is, as I said, the concept of benefits or penalties is what we call it as an ideality. And primarily what we do, we actually use this approach to use multiple things. If you're talking about an incremental solution, if you're talking about a sustaining solution, with disruptive solutions very quickly.
Mr. Tito,
Yes.
just excuse me. I would request you to switch off your video because at times your network is breaking.
Oh, okay, sure.
So then
Thank
it
you.
will be smoother.
Oh, thank you.
Yeah.
Is this better, Namita?
Yes, now it's okay.
Thank you. So when you look at innovation strategies, so as I said, the innovation strategy of incrementally is all about, as I said, the language of innovation is functionality. So what you're talking about is redistribution of functionality. So we are talking about reducing the denominator. So what I would do, I would look at the functional value on the numerator and the cost and harm. And I would actually talk about products, components that doesn't contribute much value, but cost more. So what we can do, we can able to reduce the cost that basically talks about the ideality of the system. So if people are looking at incremental innovation, what we can do, we can look at reducing the denominator. And what we can do, we can increase the numerator. The numerator is always, so if you look at the phone, mobile phone, people are paying 1 lakh rupees because they're getting a lot more in the numerator. And what we have a very powerful method called hybridization, where we are talking about adding things and developing composites by solving new problems. And when we have radical innovation, the skin color is very highly biased around the world. So if you're talking about color change, people are not talking about permanent change. They want it contextually, they want a light skin, that's it. So what we have, a very powerful tool called a function-oriented search, where we generalize the functionality, and then we look at industries, and one of the industries that we look at is nature. And then we can able to look at, let's say, for example, I can look at the polar bear. And interestingly, the skin color of polar bear is charcoal black, and the skin or the fur that it has is not white; it is translucent. So when you have a translucent material applied on a dark substrate, you see a light skin, and that's what you see around in most of the advertisement that you see. And what they do, many of the cream companies, they basically use that. And if people can go one step further, they want to see how they can change colors. They can able to see at a chameleon and then talk about what they can leverage. And finally, when we are talking about disruptive solutions, that's where we are in this present world. What is very important here is we have tools. We actually generalize. If I take, for example, the petrol, the cost of petrol is very, very high in India, right? I'm talking about one of the reasons for that is the method that they use is called catalysis, which actually needs high temperature as a requirement for the catalyst to work upon. And what they do, they are basically trying to break the hydrocarbons. So if we were to generalize that hydrocarbons, it's basically making and breaking bonds. And if we can able to look at the scientific effects and see, there's a very interesting thing. I can look at radiation cracking, which can be done at room temperature. And that's a very high level of invention where you can able to develop totally a new product level altogether. So summing up these things into the context of giving an example of emissions. For example, if you look at the BS6, where we are, and if you look at from 2000 till the 2020, in the last 20 years, there have been significant evolution in the automobile industry, where we are talking about reducing the NOx. So if you look at this particular, this is a very interesting slide. If you look at it, what they're trying to do, the functional principle, as I just explained in disruptive innovation, is all about what you use a chemical that is nothing but your hydrocarbons, and you get a thermal energy, and the thermal energy is converted to a kinetic energy. So within an S-curve, what you are trying to do is you talk about the solutions that you do is you talk about particularly from BS4 to BS6, the significant things that they have been adapted. So there's an adaptation that they brought it directly from the SCR, from the aviation, the energy industry, if you can look at, and the diesel particulate filter. So this is basically adaptations that you take it from other industry. And particularly everyone is trying to enhance. So obviously the emissions is reducing, which means your value is high. And then you're at particular one, now that people have released their products for DBS6, what they're working on, they're basically trying to reduce the cost. That's what they're trying to do, an incremental innovation. So this is a method that you can talk about as a way of looking at how people can look at talking about solutions within an S-curve. But if you're talking about in the disruptive world, we know that EV is taking a significant portion of the traditional IC engines. Now, if you were to look at it, what's happening there is nothing but there's a source of the functional principle has changed. Where it has changed at the energy level. You remember I talked about the operating agent, the transmission, the energy source, and the control system. So the energy source, instead of a chemical energy driven to thermal to kinetic, it is basically an electrical energy to a kinetic energy. So when we are talking about shift in the S curves, the only thing that you can talk about coming from is the change in the functional principle and the main parameter value looking from the trends of engineering system evolution. So I thought this basically summarizes how we can look at innovation strategies and the S curve, so that if we can understand the big picture and each of the organizations who are participating here, if you can relate yourself where your product is here and talk about what are the innovation strategies, which I just talked about, the radical, sustainable, incremental, or disruptive, that basically makes us in the path of with the structured innovation methods of TRIZ can help us to go strong. So there are multiple products out there which are very used with TRIZ. It's one of the student of mine who developed a solution. This is where he started with as a method to measure dissolved oxygen. But apparently that was the crude method where he got in. And when we use the methods of TRIZ, that's where we could get a significant jump in the innovation part. And it has been sold to all the AP farmers through the fisheries department. So I'm going to show a case study here where we are talking about working with the client, and there's a published information in public domain, and that's what I'm referring to. So when we are talking about here, where we are talking about as diaphragm gas meter as a system, traditionally this has been there for more than 30 years in the market, and it has lot number of parts, and basically it's a pantograph driven method of mechanism. So when we are talking about the method of the product, the cost, the solution is people essentially need differentiated solutions. They need products which are very less cost and more effective with the differentiated solution. So as I said, very importantly, whenever we do any work on talking about how the innovation strategies should be, we first look at understanding the main parameter of value. And looking at the particular product which has been there in the market for last 30 years, what we have seen is there are very clear recommendations that this method gives us. It says that you can talk about the near term and midterm. You can talk about, you can reduce costs. You can actually talk about trimming the product. We can talk about the switch principle of operation. That's what I talked about, the functional principle change. Or you can actually look into new MPV. Okay. So just to, as I started at any time given, it's very critical that any product that we understand should be understood in the context of functionality. So what is this gas meter? The gas meter basically is a diaphragm based gas meter. So what it does, there's a diaphragm. So it basically moves the gas moves the diaphragm. And then if there's an outer diaphragm plate, there's an enough diaphragm plate, and there's a flag. And there's a gasket which basically stops the gas. And now when you look at the full picture on the top of it, there's a manifold grid and there's a hub assembly. But what is interesting here is if you look at this, the manifold grid guides the side pillar, which actually moves the cam slider. The cam slider rotates the cam, and the cam rotates the cam pillar, which rotates the crank, and which rotates the gear, and which rotates the meter. But if you look at what is this product meant for, this product is meant for to measure gas and disperse gas. That's it. Now, when we are talking about that particular one, and when I look at functionality, I look at multiple times the functions are being repeated, which means the system by itself has a significant opportunity to innovate. So when you look at these particular things, what we bring from TRIZ methodology is we formulate problems. We formulate very unique problems. So if I were to look at the complete functional modeling, it looks like something like this. So if I'm talking about incremental innovation, so our entire intent is what? We want to make sure that the gears rotate the meter so that people can't tamper the machine at any given point of time. So what we are talking about is the formulation of the point is if I can devise a method where the cam rotates by itself, then I can able to eliminate these product components which are there in the system. By doing so, that's the benefit what I get. But there's a penalty. The penalty at the end of it, we want to make sure the measurement of the gas flow should not worsen at any point of time. And one of the recommendations that you see from this method in the stage 3 is deep trimming. So what we are talking about here is if we can able to trim it much deeper. So if we can able to rotate the crank by itself, then what I can do, I can essentially eliminate good chunk of parts essentially. And that is deep trimming. And deep trimming, trust me, gives you very novel solutions which are not there. And it gives us very strong intellectual property altogether. So we're talking about this particular product here. So we looked at this particular stock yoke mechanism as a means of how you can reduce the number of parts. And then when we looked at this particular problem formulation of the functional principle, we can talk about how you can use the Mobius band as a method where you can able to use just you have the shaft and the Mobius band there, and that can able to essentially do that. And essentially, once we do this, we go to the next step in the understanding of the intellectual property. You look at the IP out there. So when we formulate the problem, if the gas moves by itself, that's an action. Then the benefit is the quantity of substance that is nothing but we can able to move the gas, right? We can eliminate a lot of parts. That's one of the intent where we are talking about this particular context of the problem here is, but what is the penalty? The measurement can be a potential penalty that can come in. So when I formulate an inventive problem, this we call it as an inventive problem. An inventive problem is one which has a benefit and which has a penalty. And now what we are talking about is win-win solution. So what it gives us a clear direction. The methodology guides the path, and it says that look, in different domains for this particular conflicting requirements, a mechanical substitution is used. So what we did, we basically looked in the patents that are out there along with the team, the client team, and this is what they looked at, and they talked about what are the patents that are available. And obviously, as you look in, there are a lot of patents which are talking about on the fields, which is an ultrasonic and optical or a microthermal part of it. So when we looked at this particular understanding, that's where we looked at changing in the functional principle. And that's how we could able to develop solutions to the product to the client, where we have multiple intellectual property being generated. And that's where we have been done with the methodology of TRIZ, where we could able to develop to the client. So just to put that in the context here, where we have multiple solutions that have been patentable solutions are being brought in. So I just completed the case study and just have a few more slides to talk about. Since we are talking about innovation and fundamentally where we are talking about building a culture of innovation across the country and organizations, there are few organizations which are good, but they're only pockets of excellence. What we need is not pocket. When we talk about a culture is that something which is done, demonstrated consistently over a long period of time. So what I've seen is the two important aspects that really break the chain of building a system of innovation culture. One aspect is people, they don't question status quo. Nothing is going to change. What we need to impart is how to question the status quo. And that questioning the status quo comes with changing the mindsets. And that comes with a very important learning of how you accelerate change in the corporation. And what people use are win-lose solutions. Look at BS6. It's a very great solution. We have a lot of benefit that comes from the environmental reduction of emissions, but it's very expensive. It drains the pockets. So you need to go with a win-win practical novel solutions, and that come with only by problem solving. So what I'm talking about is the entire approach of is all problem solving. And that's what we use as TRIZ as a methodology and structured jugaad. So what we need is we need impart the skill, and this is what we need to do, the doers to the organization. And that's what, when we are talking about culture part, you need to reward people. So once you reward people and you change the mindsets, that's where we can able to build the cultural part. So this is one of the recommendations that we have given along with the frugal innovation, which is going to be presented this afternoon, Dr. Anuradha, and along with Amit, so co-authored with them. So the recommendation is you need to bring awareness. You need to bring awareness and put very good rewards. One of the things that we need to bring in is how you can able to change the rewarding mechanism that we give to inventors in the country. If you can leverage elements from Germany, probably that would be bring a lot more value to the entire thing and accelerate things. So TRIZ is not just in India, it's been happening around the world. And if you look at it, I work with Dr. Sergey, who's a TRIZ master and he's my mentor. And what we have seen here around the world, if you look at it, it's very popular in Korea, as I showed both the examples of Hyundai and Samsung. And what is very interesting is not just the corporations, they have been used across the MSME across. And it's been worked very closely with the patent offices. If you look at China or patents. And being the game being played, if you look at all the evolved countries, the intellectual property is where they have the strength. And if India as a country doesn't have strong intellectual property, we still go back to the same domains of being a recipient of looking at paying loyalty. And this methodology is being taught in the colleges and across the universities. So just to put that in the context, what we are doing is we have a non-profit organization, TRIZ TI, that's a regional matrix organization. And what we are working here is we are working with institutes and educating them. Everyone talks about innovation, but people really need to put their foot down. We need leaders in the organization, in the country, to talk about how new methods of structured innovation can be done. So we have very strong innovation methods that we have. We have workshops where we can get certifications from the International TRIZ Association. That's where I'm a member, accredited member. And we have the design for patentability as workshops, and we have structured jugaad workshops from India coming in. So as a ProInn works with three verticals. We do consulting, we do innovation capability development, and we do operation excellence capability development. And what we have, we develop a cultural part where we break organization into two: developers, that's nothing but the enablers, where we talked about the leadership and we impart them on change acceleration. And when we talk about the doers, that's where we are talking about the people, the engineers, the scientists. We basically impart them inventive thinking. Or we talk about design for Six Sigma. I mean, I'm glad that the earlier talk was talked about design for Six Sigma, which is very critical. Unless we develop solutions that are robust enough, you can't come with your bottom line errors very high. So we need to develop novel solutions with TRIZ, and we need to blend design for Six Sigma to develop powerful solutions. So we have excellent testimonials. We partner with large corporations as innovation partners. A lot of testimonials that talks about what we bring to them as innovation partners, be it Rolls-Royce, be it TVS Motors, or be it Tata Steel or GE Healthcare or Raychem, any one of those. So I think that's what I thought I would share with you, bring in the context today, where how we can able to transform our country and bring innovation as a core discipline with the intellectual property being generated. Thank you. Namita, back to you.
Thank you, Mr. Tito. Indeed, a very insightful and an informative talk. So we have certain questions from audience. I'll just yeah. So the first question is, audience would like to have your opinion as to how TRIZ methodology can be applied in case of very specific design innovations.
Oh, it's excellent. It's when the moment you you narrow the problem, you can able to identify what is the benefit and what is the penalty, as I just explained. it makes it very easy for you to solve problems. And the bigger challenge is identifying the problem there. That's where we work on. But once you identify a design problem, you can come with multiple competing solutions with Novel.
Okay, thank you. So another question that's on the board is what product innovation design theory can actually be combined with the TRIZ other theories that are there anyways in the TRIZ framework?
Thank you. That's a great thing. So the design thinking is quite known, very well popular. It's all talks about empathy driven understanding. But at the end of it, you can empathize with the person. But if there are two conflicting requirements, empathy can't help it. We need to talk about solving the conflicts with win-win solution. So to answer that, yeah, people, the best companies who have a design thinking as adapted as a means of understanding their customer pain areas, they use TRIZ as a method to talk about how to solve them with win-win solutions. So you can start empathy as a means to understand problems from a customer driven scenario, and you can use TRIZ as a methodology to come with win-win solutions. And this methodology gives us very unique ways to, as I said about the 5 ways we can model the problem, we can come with multiple competing novel solutions. And they actually complement each other. So you can use one set of tools to understand what the problems are, and you can use another set of tools to actually use for solving novel solutions with win-win.
Okay, thank you. So there is another question on an important area of MSME based innovation.
Please.
So the question says that how is TRIZ concept and how effective is it in case of MSME innovation? And how do you think that applicability of this TRIZ innovation approach in MSME industry will
Absolutely.
actually take India to a next level of MSME innovation based leadership?
Thanks for asking that. That's a great question. That's something which I was been talking about. If you look at MSME, particularly in our country, one of the challenges that they have is they don't have funding of research. And this is the paper, one of the recommendations that we talked about is how you can able to put funding for MSME. So if you can actually talk about MSME, they are the backbone for the country, to the large corporates around India. What is very critical is you need to have them funding. You need to, from the policy standpoint, you need to empower them with the funding that can be used to methods of adapting structured innovation, for example, because people think innovation is very time consuming because they are not equipped with methods to solve problems. But if you talk about South Korea, for example, the only way, in my article, I talked about how you can increase exports in our country. If you look at our export versus imports, it's highly skewed. We import so many things. If you can take the MSME who are importing, and if you can flip the tables, the switch that I talked about, we can able to make them export ready. And we are talking about billions of dollars here. And what we can do, it's not that I'm talking about here, it has been demonstrated in different countries altogether. And Korea is a great example. And that's why I'm talking about what Dr. Sergey, my mentor, has been there with them and he enabled that. And that's what I'm trying to work with as MSMEs here. The only element, Namita, just to add here, is there is a very fundamental mindset that is required. The MSMEs should think that they can able to innovate. And one of the elements that we need to talk about from the policy standpoint, the country, the government of India should actually give a lot of benefits for those who develop novel solutions from MSME. They should be given benefits of preference in defense, for example, or in the national highways, for example. So I see that it's very critical for our country and MSME adapting this approach, and we can able to develop quite differentiated solutions. And more importantly, we can develop export ready solutions where we can turn the tables from imports to exports. So there's a policy that is required, there's a mindset that is required, and there's an element that we need to talk about from the people coming forward.
Thank you. Very useful points indeed. Okay, so another question. So basically, these are two questions. I'll combine them. One is how does TRIZ and actually does it facilitate long long-term innovation in an organization? And second question is, does it actually apply to, something that we call as a radical or disruptive innovation, or is it just
Absolutely.
applicable to incremental kind of innovations?
Absolutely. Thank you. Great questions. So there are companies who are leaders in the industry who have TRIZ as a DNA of their innovation. So as I talked about earlier here, the first point which I started, just to put that in the context there, saying that why is this? And as what you're talking about is the element is once an innovation culture, IP generation becomes a natural outcome in the organization. That's where you start building strong intellectual property. You start getting low hanging fruits first. But this method guides the path in a very effective way along with the DFP. You can develop very strong intellectual property. The moment you bring intellectual property as a strength to the organization, the next step is problem solving with TRIZ. And you bring practical novel solutions. For example, if you take Samsung, we can bring predictable about what would be the next evolution because they have the DNA of innovation comes from TRIZ. You take Hyundai, you take GE, where I have spent good amount of time in my life. You take LG, you take examples of Procter and Gamble, Intel. Many large companies have used TRIZ in and out for long years. It's not just 1 year. But is take it for a long period of time. You have multiple clients in India who are adapting that, which is very good. So to answer that, yes, absolutely. It gives long-term sustenance and it gives long-term growth. And these are very bright reflections of a testimony there. The second question is, can we be able to develop disruptive solutions? Precisely. The very fundamental disruption comes when we think about, as I said, the language of innovation comes from functionality. If we can understand functionality of the device, as I said, as an example, if I take the gas meter, for example, it's used as a device to measure gas, and it's a device used to dispense gas. That's what it does. If I were to take that as a functional understanding, I can come with quite fascinating solutions that my existing knowledge doesn't bring. You look at the organizations, when we bring these solutions to the table, what we enable them is we enable solutions that are beyond the normal understanding of the knowledge in the company. That's where we bring solutions from outside industries. And when we bring proven solutions from the outside industry, and trust me, the boundary conditions are not same. That's the reason why people think of adapting things, but they fail very fast and they take long time to really develop. But what we do in this entire approach is we cut time to the core. For me, you take any problem in 48 hours. Let me repeat, in 48 hours of 32 hours of learning and 16 hours of our facilitation, we can demonstrate a practical, novel, patentable solution. That's what we can bring. And that we can do for product and as well as process. So not to talk more about it, but the point here is if we as a country, as India is not adapting, if you look at the other adapting countries, South Korea, the Chinas, and Malaysia, they're very, very high. They were adapting it. And the only problem here is people think they know TRIZ everything because it's been there for many decades. But what we know in the public domain and what we know in its evolved path, quite significantly different.
Thank you. Thank you for this detailed helping us understand. Okay, so another question is you've talked a lot, and in fact, Riz speaks a lot about the importance of patents and IP patentability. So this question says that what in case of innovations that are actually, do not have that IP or they're not patentable per se, but they are innovations. So how does TRIZ actually help and facilitate such innovations and such industries?
Excellent. Thank you. Great question. So we have the method of design for patentability. So let me bring a little bit context and explain that. A great invention need not be a great patent because it is dependent upon the person who writes it, and it all depends upon how they write it. That's the reason why you look at industry, there are proven methods, even the DFP that brings us, you can look at a particular patent and you can circumvent the patent. At the same time, we can strengthen the patent. Now, let's say I come with an invention, and I would make sure that the R&D that we spend and the time we spend, maybe about a year, I would make sure I build a portfolio of patents using the DFP. And that's how you can able to build, make sure that no one can circumvent. Now, for invention, there's a very interesting thing. There are a lot of startups that comes in. What they do, they say that, look, they have an idea. But ideally, if you go and do a Google search, that would have a patent already there. Now, when you have a situation like that, what you would do? Now, that's where you need to look into the existing patent and your solution. And what we can do, we can talk about how you can strengthen your solution beyond your existing needs. That comes from the methodology of TRIZ. Now, once you look at your claims of the patent that is out there, then you can look at DFP and you can see how you can circumvent that. There is a legal way of circumventing a patent. Obviously, you need to go through your legal means. You need to have involve your lawyers, and you have freedom to operate solutions to get that. And those are methods that are there. But the methodology, what I'm talking about, can help us to look at one of the best patent that a startup is there and a best patent out there. And you can look at how you can come with circumventing. Or very important, you can come with how you can strengthen that. So if your solution is very weak and which is already there existing in the market, what I would do, I take your product, I look at my functional understanding. I talked about the innovation strategies that I talked about, either the numerator or a denominator, and I start disrupting that. And we use blend with the DFP, and then we can able to ensure that someone can develop a solution which has an element of differentiation that can be claimed.
Thank you. So in any case, TRIZ actually facilitates, helps work around IP. So that's good.
Precisely, that's right.
Okay. And so although you spoke about several technical contradictions in TRIZ, there is still a question on what is the major key technical contradiction in TRIZ?
Oh, okay. So the contradiction is a method of formulating a problem. So wherever we are, okay, in whatever context of the problem you are, in whatever situation we are, what do you need to do? You need to talk about an action that you are talking about. You need to talk about the benefit, and you need to talk about the penalty. A contradiction is one which has a benefit and a penalty. And our known means, let's say if I take DFS, I'm a certified DFSS black belt and a master black belt at GE. I've certified multiple of DFSS people, green belts. Now, the people go with design for Six Sigma. They talk about optimization. Optimization is a subset of a solution. Once you narrowed a path of innovation, of solution, then you can do robust design using design for Six Sigma. But many a time people say that, look, I want to use optimization as a means. But optimization gives you a subset of a solution. It doesn't give you new solutions by itself. The question of contradiction is when you formulate a contradiction, you're defining new paths that can be later optimized. So when you talk about any problem in any context, as a mask I talked about, if you wear a mask, a 95 mask, then it can shield virus, but it actually reduces your oxygen intake. So for a given particular context of a problem, you formulate a technical contradiction. So the contradictions vary based on the problem that we are trying to solve.
Fine. So thank you, Mr. Tito. Indeed, a wonderful and a fantastic presentation, very insightful and good, informative model discussions we had. So thank you once again for your presence and sharing this with us. And I would also like to thank all our audience who joined us and participated in the session. We have next session on frugal innovation for a national challenge, Innovate in India for the world, which will start at 3:15 p.m. So we would request our audience to join us on CII Hive back at 3:15. Thank you.
Thank you, Namita.
Mr.
Thank you, CII, and thank you all.